So I'll be going according to the BW for BW462 contents, right, which is meant for certification also. So even after this course, you can take up the certification, right? And so I'll be giving some own materials. Well, what are the topics is there? So if you want to do some, say for example, I have got an exercise file for this, which I can share it with you. But this presentation I'll not be able to share because this is what normally we take up for SAP, right? For different clients and all. So we're not authorized to take this, share this particular presentation, right? Okay. So what we'll do is today, because there'll be some people who will be working in HANA, then after that BW4HANA, and we know that now HANA is a core part of our, say for example, all your BW consultants, right? So before we used to work more on the BW side itself and never touch the database. But now as HANA also will be functioning for different functionalities. So then we need to understand this particular HANA perfectly, because we need to understand, because there'll be a lot of performance tuning problems, errors. Then we need to see that how we try to rectify that. Sometimes it may be a HANA error, sometimes it may be a BW for HANA error, multiple things and all, right? So, because you people will be working in different areas, because mine is morely into the training as well as some expertise in the freelance projects and all, right? So whatever information I have, the knowledge I have, I'll share to you, right? You think that if some data or something you require it, so just give me a mail before itself, so that I can procure that and help you out in a better way, right? So even the day one, if I'm not able to tell, I'll tell that, okay, I'll be coming back the next day, right? And I'll give that information the next day, canceling it, right? So I'll try to send the doubts, whatever we have it. So because something maybe more project related also, you may be having it. So I'll see what best I can do it. And if anything is there, then I'll just come down later, right? So today what we'll do is, the first day I want we people to be perfect with the HANA side. Okay. So from Monday we'll be starting the BW for HANA topics and all. Okay. So what we'll do is I'll try to give, because see what happens is in the classroom based we teach, and after that we give some practices for the sessions, and it covers 40 hours and all. But normally here in the online training, we don't know what you are doing, who is practicing, not practicing, right? So what I can do is, like, we need to take some breaks and all, okay? So intermediate breaks, because as a faculty talking for the whole 8 hours, the second day will be flat, right? So in between, let's do some practices. Let me give some more practice to you. So let's do that, not a problem. Okay, so any doubts, nothing and all, I'll try to take care of it. Okay, and as I said that I'll be covering the whole BW462 topics inside this. And coming to the topics, I'll just give you what we are going to review for this whole 5 days. Okay, we'll be going for getting started with your BW4HANA. Unit 1 covers about our normally there in the training environment, then getting started with SAP HANA, what is SAP HANA and all. So we'll be a little more interactive. Huh? So there is no problem that whatever you have the knowledge, you can share to me, and whatever the knowledge I have it, I'll try to share with you. Okay, let's make an interactive session, and whatever the discussions, right, makes more fruitful for us. Now, coming to the third lesson, like we get started with the BW for HANA, then getting started with BW for HANA modeling tools, then getting started with BW for HANA cockpit, right? So what is the BW for HANA cockpit? Then we have this unit 2, fast to BW for HANA, right? So we'll be describing the conversion strategies and tools, then introducing the in-place conversion approach, and introducing the remote conversion and shell conversion approaches. Now this will be related to the basis theme, but still what we have is, we'll try to tell you what are the type of migrations we try to do from BW to BW 7.5 to BW for HANA. All right. So what tools we use it, what we should do it during migration, what happens, and how the migration how the after the migration how it looks like. All right. This is all we try to see it out. So this all deals with your migration strategy within this. So this is the migration aspects which we'll try to give to you. Okay. Next. So once the migration goes off, then we go for unit 3. So that your SAP HANA modeling, right? So we have an SAP HANA native modeling. So again, which you'll be using for your mixed scenarios within your BW for HANA. Okay. Then after that, so going for your SAP HANA completion, we'll go for core modeling aspects in your BW for HANA. So describing your info objects, then explaining your ADSOs, then we'll be discussing about your composite providers in BW for HANA. Then we'll be discussing your OpenODS view, then introducing to your BADI provider. Not be much more doing in this. There's not, but it'll tell you what is an BADI provider of this. And we'll be explaining about your LSA and LSA++ architecture, which will be used within your BW for HANA, right? And Unit 5 will be discussing about your hybrid modeling, that is your mixed scenarios from HANA to BW, from BW to HANA, how to try to consume the data from both ends, right? Then we have Unit 6, so running the BW for HANA data warehouse. So we'll be seeing what are the changes happening within the authorizations. Then BW for HANA statistical analysis, then BW for HANA content, right? Then we'll be introducing you to the HAP, so HANA analysis process. Now, APD will not be there, so replacement for this will be your HANA analysis process. Then describing the SAP BW for HANA Analytic manager, then explaining SAP HANA optimized transformations. Okay, so we'll be using some AMDP procedures within this. Okay, so I'll tell you what is an AMDP and how to create these transformations within the AMDP. Next, what are the different changes happening within your process chains in BW for HANA? So then after that, Unit 7 will be describing about your BW for HANA data lifecycle management. That is your multi-temperature management within BW for HANA. So which describes about your multi-temperature data management. Then introduction to SAP BW for HANA data tiering optimization. So now this is your DTO, which will go for your cold, warm, and hot, warm and cold, frozen, right? These are different types of data what we have. So we'll be trying to take up this, and I'll show you how to configure. Look, configuration of NLS Sybase IQ, right? So I just installed that. Then how to connect this Sybase IQ to your BW for HANA. So from there, how to archive the data, right, to your NLS server. So that practicality, I'll show it up, right? So that is one. And we'll be going for Unit 8. So that is your data provisioning into SAP HANA and BW for HANA. So this is all how to pull the data into your into your BW for HANA to get the data replication. So in this, we'll be describing about different options of your data provisioning, and we discuss about SLT, then SLT into SAP HANA. So I'll show you how to configure the SLT, right? Then after that, get the data into your BW for HANA using the SLT to get the real-time replication into your BW for HANA. Then describing SAP HANA remote data sources like smart data access and smart data integration. So we'll be configuring the SDA connection with your HANA database. Then after that, again, I'll show you how to create a connection in BW for HANA to extract the data from your smart data access, right? Data virtualization. Then we'll be discussing again the one more connector, that is your SDI, smart data integration, right? SDA and SDI will try to, I'll show the whole connection within the HANA database as well as your BW for HANA 2. Cool. Then we'll be explaining about your ODP, operational data provisioning, into your SAP BW for HANA. So already the connectivity is there. If you want how to connect it, then I'll show you how the ODP is being connected to your BW for HANA. Then after that, we can create some data sources within that and try to replicate the data within that, right? And getting started with your big data source system, but we don't have the big data source system connectivity here. So this also is only conceptual in your BW4HANA training, right? Okay, so the main core functionalities what we'll be looking is your SLT, then after that smart data access, then SDI, and your ODP connectivity. Okay, so these are the 4 types of connectivities we'll be seeing in your data application. Then after that, it discusses about your embedded analytics. So what is embedded analytics and all, right? So within that, how your views, right? So your private views, interface views, consumption views, what are the different types of mediums which we'll have in your S4 HANA, so we'll be discussing, and we'll be creating some views embedded in order to have some embedded analytics within your S4 HANA. So I'll just check it out. So I'll get you differences between your S4 HANA analytics and your BW for HANA analytics. Okay, this is what we'll try to see within that. Then we'll be seeing the workspaces. So for the agility of your end users, so we have some workspace creations and all, right? So this also will be having the discussion regarding this. So then, we'll be going for SAP HANA Analytic Cloud. So normally we don't have that license involved for Analytic Cloud. So we'll see that for a free license, we'll try to have. So you need to register for that. And if you're not already registered, then we can go for registration so that it will be available for you for 30 days. Okay. So with your company ID, you can just log in. So there's a free for 30 days trial what we have. So we can utilize that and start using it. So I'll show you how to do the SAP Analytic Cloud integration with your BW4HANA and how to create reports based or create the dashboards in the, will not be going core because this particular topic itself is again a 4-day topic, separate course for this, right? So this is what we try to cover it on. Okay, so that's what. So then we have some BW workspaces. Then getting started with Analytic Cloud is one. Then we'll be having BW4HANA tool collection, right? So that is what we'll have the last. So tool collection is this. What are the different tools which are available? So before migration to HANA, as well after migration to BW4HANA, what are the things to be done? That will be discussed here. Cool. So that is this is what the whole topics will be covering. Any doubt or anything you want to ask me? Yes, you're free to ask.
Hi Ravindra.
Yeah.
So in this core curriculum, like course curriculum, little bit, I'm expecting queries. You may heard about that query manager.
Can you be a little louder? Not audible.
Is it audible now?
Yeah.
So in this course curriculum, like just if you're adding some more few points like query design and analysis points, also just touching that stuff, it may help to like
No,
how.
your voice is getting breakup. I mean, your voice is very low. Can you be little louder?
Yeah, I think you're asking for query designing, right, within the BW4HANA.
Correct, correct.
Okay, fine, not a problem. So I'll show you how to create the queries and all within this, and we'll be using this analysis for MS Office for using the queries. If required, I'll check it out because the BW also BW Webby reports how to connect to that particular system, right? So we can connect to that, and Lumira is another one tool which you can use it. So some of the reporting tools how to connect to the BW4HANA and consume that I can show you, right? So any more specific things you require it, because see, handling all the people, 16 people, and within the 5 days, normally maybe sometimes like the project base, I'll check it out how much possible for me. I will try my best which can happen. But if any queries or something, you can just drop a mail to me, so that it will be better for us. Even for me, Saturday, Sunday is there, so I can check what are the things I can do for you. Right?
Yeah, Ravindra, one just it's Ravi. Has SAP in the April 2000 last few months As it announced that BPC is going to a retirement, and they wanted that to be incorporated planning session in analytics cloud, and controlling should be taken care in as for grouping reporting. So
Mhm, mhm.
can you explain a little bit over there how is going to be the planning portion of BPC go forward, if it is possible in this respect?
Yeah, because BPC license we are not getting it, but how to, when I try to show that, right?
Hmm.
Because even the free license, they're not giving it, SAP,
Yeah.
for planning purpose. So what they're telling is they're taking that as a separate license actually,
Okay.
right? So we'll see that. If possible, I'll tell you how it is and what it will
Okay.
happen. Not a problem, right? Okay. So my number will be, you can mail anything to E2 Ravindra at the rate. Okay. And my phone number will be 99725 and 6451. Right? These two names for my communication. Okay. So what I will do is I'll just go through today. I'll give the core concepts of the HANA database, right? So then we'll do some modeling within your HANA database, right? So then when Monday, so we'll be starting with your migration aspects. I'll see that because I still starting itself. I don't want to see because most of the people, some are into PODS and all, they not be into BW4 HANA. So in mid, I'll see that we can do the migration aspects. So we can start with what are the changes within your info objects, right? Then after that, how to create your ADSOs, then composite providers, open ODS views. Then we'll have an idea like what components, how it is transformed, how it will behave, and all architecture wise we'll understand. Then we can see how this migration happens. That is how I'll try to plan it out. Then in between, we'll see how to go for the data provisioning from multiple systems. Then we'll see in between, we'll see the reporting part as it is will be coming in between most of it. Okay, coming to this SAP HANA. So basically coming to HANA. So what is HANA? So anyone? Something. So let's make it a little more interactive. Whatever you have it, you can just
In
throw
memory
something.
database.
High performance analytical appliance.
High performance analytical appliance. Okay, good.
One is a platform and combination of hardware and software.
Okay.
Is an appliance. So all of the computing will be done in the RAM itself. That is like
RAM itself. Okay, cool.
is a database.
So basically, we tell that SAP HANA is a database, right, for storing data. And specialty is it's a in-memory database. Okay, so SAP HANA is a database. So any more advantages with this?
Is a platform, so we can able to develop many applications inside.
It's a platform to develop many applications. Okay. So many applications mean to say what applications you want to develop.
Anything like if you're using front end of AngularJS, underlying you can able to use this XSJS where we can able to develop these applications.
Cool. So for development, all these things and all what we have. So we should have some web server, right? So which web server will be using it? Any idea?
XSJS, that is JavaScript.
XSJS. Okay.
in terms of you're expecting something like a web ID.
Web ID, Web ID also. So yeah,
Hello, Ravi.
yeah.
So there are some areas are there which is IDE integrated development environments, which is Eclipse or else some other HANA Studio or else Web IDE. We have several IDEs are there. So with the help of those, we can able to build our applications.
Okay, cool, fine. So basically, going for what is this SAP HANA is a simple definition is high performance. HANA means high performance analytic appliance. Okay, H for high performance analytic appliance. All right. Now, as so you were telling, like it is a set of hardware and software which uses latest in-memory technique used for real-time analysis with huge volumes of data in seconds. Okay, so it's a set of hardware and of software, and it's an in-memory technique that is the main core point for us, and used for in real-time analytics. So when thing is, I don't want to take some hours and hours to get the data. So we want to get the data in seconds, right? So that is like big data. So or your huge volumes of data, which is what, or the huge volumes also, we can compile it and just give the data within fraction of seconds. Okay. Now here, what you see with the SAP HANA is the main bottleneck for SAP HANA is whenever you're getting the data from the disk to your main memory, right? So at least some 30 to 40% of the time I'm trying to waste loading the data into your memory, right? So this is a core performance bottleneck for your ERPs as well as your BW, right? So every system we try to, this is the main bottleneck which is going to happen. Now when you see the task or the different components within the uh, computer, so if this is your motherboard, so within the motherboard, so we have your RAM which will be plugged in directly on the motherboard itself. CPUs also will be, so it's an add-on directly within your, it's a part of your motherboard. But your hard disk and solid state disk, these are external. So if you try to compute a task in your hard disk, it takes 10 million nanoseconds. Whereas in your solid state disk, it takes 200K nanoseconds. Then when you see your RAM, so RAM will take 60 nanoseconds. Now, if you see the CPU, so CPU will take 1.5 nanoseconds. Now, there are three types of cores in this. So L1 cache, L2 cache, and L3 cache. There's some three caches, memory caches for your calculation purpose within your processor, CPU processor. So L1 cache 1.5, L2 is 4 nanoseconds, and another is your 15 nanoseconds. Okay, so the main thing what we try to see here is your difference between your disk and your RAM. When you have the Oracle, for example, Oracle as a database, a Oracle database stores the data in your hard disk. And processing, yes, it comes to this, but most of the data is stored in your disk. Again, from the disk, it has to retrieve the data and display it to the user, put into the RAM, and again display it there. So from the hard disk only, it has to bring the data. So here, the performance when you see it is 10 million nanoseconds, but here 60 nanoseconds or 100 nanoseconds. This is the performance gain what we want to see between your normal databases in your SAP in-memory databases. Now, as you know that in-memory database is not a new technique which SAP has brought it into the market. So even Oracle was having before itself. Exadata is right. Then after that, your IBM also has this. But only thing is, now SAP is trying to plug in a lot of components within this. Even the selling as well as the marketing as well as the components, what they do is they try to be better and they try to do marketing good, right? That's what's SAP market going through, right? Now, so previously what we used to do is, okay, I'll just come to this one, please. Yeah. Now, but previously what we used to do is from the disk, whatever the data is there, for example, if you have cube also, so cube is having some millions of records. Now there are some 10 cubes. Now 10 cubes, for example, 1 million are there. So there are some 10 million records in your cube. Now what is happening is whichever cube you are querying it, only that particular cube data is being put into the memory. So we're trying to swap the data from your disk to your main memory, consume it. Then after that, once your query is closed, then that particular buffer data is being lost. So always this is what we're trying to do it. Now, why we need to have this BW accelerator? Because customers are not happy with your aggregates. They're not happy with your partitioning. So even this performing students, what we are doing at, they're not happy with that. So they still, when they approached SAP, they told, okay, if you want to increase your speed, go to your BW accelerator, double the RAM, double the CPUs. Now that is what we can do it. There's a processing power, that is what they try to increase that. So still, only the cubes which are important, only that we used to again put into your BW accelerator and individually go for the reporting part of it, right? Still, there also what we're doing is, if I have 10 cubes and 10 million records, so only 1 million records will be updated into this. And again, it's all goes dynamically according to the requirement. Because your this particular database RAM, how much you try to use it, it had very less RAM because it is only for storing the data, so we don't require for processing sake. But application server, again, when you see this, the application server also was requiring some RAM into this. So taking conceptually, so just to take like this. For example, this is your application server, and you'll be having your database server here. This is your application server. And this is your database server. So now application server will be having some RAM here. So first layer is your OS, operating system. Then over this we'll have your RAM. Or we had a limited RAM here. Say for example, I have a limited RAM. This blue in color, what I try to take it up. So this is the RAM. This is your operating system. And in the bottom of the database, I have this operating system again. On top of this, we used to have RAM. Again, this RAM was again smaller. It was not very big RAM which you had it in your databases, right? So here we had your NetWeaver. Application server. Cool. Now, this database used to be inside your. So actually, this server again is a separate one. So normally we used to have some database, this one, in which we used to mention it. Now what happens is, whenever we're trying to request the data from a cube, for example, if I have a small cube inside this, for us, a cube looks like this. Now I make a query from here. So when I execute a query to your info cube, now info cube will go to your database. So this is normally this is done by your OLAP engine, right? It goes to your OLAP processor. Then OLAP processor will request the data for the database. Then database will be taking the data from here. You have your OLAP analytical engine, whatever you call it. Right? So this will request this, and it will get the data from here. This goes to your database, and the data, for example, you have 1 million records here. 1 million records are there. So that used to come out. Now this whole thing was there in the disk itself. Now this particular one is there in the disk. Or I'll take this one as a separate storage here. This goes for your database server. And the database server has a RAM, limited RAM, because database server also is a software, right? So we have three-tier architecture when you see application server, database server. Again, most of the people will think that this database server means it is directly your Oracle database. No. So database server is a separate process. And after that, you have your RDBMS, which will be separately installed. For example, Oracle. Oracle is a separate database where this will be running on the disk, right? Now, whenever you pull the data, so this database server will try to go to your disk. From the disk, it will try to populate this data into your RAM, right? It will populate the into the RAM. So always we pull the data into your application server RAM. Now with the help of ABAP, so whatever the transformations you're trying to do it, or directly simple report, it has to do the aggregation of the data. Say for example, I have M1 quantity as 100, then after that again M1 quantity as 200, right? M2 as say for example 100. Now what happens is M1 and M1, it has to aggregate and get the data in the report as M1 as 200. Aggregated data. So the aggregation happens in the RAM itself. Now M2 is 100. So aggregation is done by whom? So now it is just like a jet engine, right? Or it's a motorcycle, whatever you have it. So motorcycle has got a tank. So tank is for the capacity to hold the fuel. Then after that, the engine is to process, right? To just move the vehicle. So here in your system also, so we have your RAM for the capacity, and see this particular OS or the system has got some CPUs, right? So in the bottom level, so still I'll take some CPUs here. Now there are some CPUs. CPU. So multiple CPUs. Central processing units, that is your processors. The more the processors, so the more the compilation. So storage will be there in the RAM. So pull the data from the memory, then after that give to the CPUs, right, for processing. It does a parallel processing, and finally we get the data output here. So this is how the process happens. And as I told you that it's always goes for swapping within your disk. Now with your in-memory database, so what has happened is the whole data what was there in the disk, now we moved it directly to your RAM itself. We are trying to put the whole database within the RAM. So now when you install your database now, so let's assume that you have the RAM. And now what's the RAM normally we have within a BW system? So we'll have 256 GB RAM. Then after database, we'll have, say for example, you can say 256 GB RAM, even less than that also, because database doesn't require more, because the more compilations were happening in the application server. Because your ABAP programs, So what do? You try to pull the data 1 million records into this. Then after that, you will put this into an internal table, loop it itab. Then after that, calculate all the things. Then give it to the web report or give to the cube or whatever it is. So all your ABAP programs are executed. So here, the more application server RAM is what you or SAP was concentrating in. So we are never doing more of it in your database level. We're not doing it all, right? Now what SAP is trying to do is they're trying to increase your RAM size of your database. So I will have more RAM inside. And the whole database now, whatever was there in the disk now, is being moved to the RAM itself. Okay, now it's in the RAM itself. Now it's not at the disk, directly we move it to the disk. Now this particular RAM within the database server is, now we should not tell the application server RAM is not in memory. Okay, it is only the database server RAM is in memory. And here we have the size of this approximately, say for example, 1 TB, or you see most of the clients going for 2 TB initially, but as the requirement keeps going it, I can go for 10 TB. Then I have seen customers going for 60 TB also. 60 TB RAM. So American Express was there, one of the clients who came up. So they told us 60 TB is there with us, and we came for the training for performance tuning. We have a lot of problems. Please help us. Right? They're not still happy with the 60 TB also. But normally organization, we see that what servers we have is maximum 1 or 2 TB. Right? So what is the capacity of your server? Any idea? Anyone working on HANA? Hello?
Usually 2 TB, yeah.
2 TB. So 1 2 TB, hardly they go for 1 TB itself is very costly. They cannot spend more on it, like, right? So approximately 2 TB is more than sufficient what they try to go for max currently now. Now as the requirement goes on, yes, they are going to increase it. Now what we're trying to do is instead of going from your disk to your RAM and do all the things and all, so here we see currently BW4HANA. So what we are trying to do is only the migration of the database is done from your hard disk, Oracle disk to your in-memory, so that this is the point here. This is the point here. What we tell is 10 million nanoseconds, whatever the speed which was there in Oracle. Now we remove this, migrated it to your database which is running on the RAM, that is your in-memory. Okay, the speed at least 30 to 40% of the speed, which was a bottleneck now here, that we reduced. But again, what is happening? The data has to go into your application server again, right? The data has to go into your application server. There, for example, when you try to write your ABAP transformation, then what will happen? It will from your in-memory, it goes to your application server. Within the application server, it will try to execute it, and you get the results. But if you use an AMDP procedure, then it will not pull the data into your application server, but it will process the data within the RAM of your database itself. So that will be the difference how we try to do it. So the architecture wise, we have your in-memory database. Within the database memory itself, your HANA is being installed now. Okay, so within the database of your RAM itself, what is the RAM? I'll take it as 10 TB. So this is what I try to do. The application server RAM is not increased. It is 256 GB only. But your database RAM is only increased up to 10 TB. Okay. So from the RAM, what we try to do is before ECC and HANA, BW and HANA. So this and all what it was trying to do is only thing the performance what we got it is when the cube is requesting, it is not going to your Oracle disk on the Oracle on disk, but it is on the database. Now it is directly in the memory database. So we are getting the 30-40% increase of your RAM speed we're trying to get here. Okay, this is your BW on HANA architecture or BW4HANA architecture also the same thing. But BW 7.5, it was supporting not only HANA, but Oracle. There's a lot of programs, and also the ABAP code within this programs. There are some millions of codes which were there. Even at the time, what is happening is when you see your application server, so within the application server, what is there? We'll be having dispatcher. So top component is what? Dispatcher. And below the dispatcher, we'll have work process. So work process is the main part of it. Now work process, again, what will happen here? So work process, we have, again, what are the different parts in this? We'll be having your ABAP interpreter, the interpreter, and one more is your database interface. So what the database interface does is, your open SQL, it will be interpreted by your database interface. This will convert into your native, because the database may be your Oracle, SQL Server, DB2, anything. So the burden is out there on the database interface. But BW for HANA, so we don't have any other databases except HANA. So the programs, whatever is there, they're reduced, right? So within the interpreter also. So it has become a very lightweight. Okay, so it has become a very lightweight system, so that whatever the big codes which are supporting for different databases, that is being totally removed up. Okay, so that is what we get. So, the architecture wise for BW on HANA or BW for HANA, so this will be the same architecture. Okay, the whole for even S4 HANA also, instead of your cube, this will be a table. So table data will be fetched uh, from your HANA database, which is running in the memory itself. Okay, that's the point here. Cool. So any doubts? You can just ask. Okay, fine.
So that it means go forward, ABAPer as well as BW modeler role will be done by the HANA modeling day.
Yes. Now in BW for HANA also, what you're trying to do is we are not going to your BW system. So even modeling is not there. Directly we do within the HANA Studio only. But now still we are depending on ABAP. Still, it is not totally eradicated, but at least some 50% of the ABAP, whatever the code was there, is totally reduced now. So they're trying to reduce the overall burden on this particular system. Say, for example, when you have NetWeaver, previously what was happening is there was web application server, right? SAP was web application server. Now, then what they have done at web application server is your BW, say, for example, BW 3.5 was running on which platform of your basis? It was WAS, web application server. Then after that, we came to a new concept called NetWeaver. Again, NetWeaver, what we have? So we have this as well as we have two parts in this. So it was having WAS or ABAP application server was there, and one more is J2EE. J2EE they include Java server also they included. Now both these particular platforms they called as a NetWeaver. So J2EE means other applications also can talk to your SAP system very easily. So they made this as NetWeaver. Now BW 7.0. Now coming forward in the BW for HANA, now they removed this one. So now this is obsolete. I don't want to put this overburden on this. And this architecture of NetWeaver was known as SOA, Service Oriented Architecture. Okay, then this booming was good, right? SOA, Service Oriented Architecture, I can talk to multiple systems, very integration and all. Now BW for HANA, So what happens is I just put this fine. So now it is NetWeaver, but it's a very lightweight NetWeaver. Now the portal, whatever we had it, now it is totally removed. We cannot have it this within the system there. It's only the ABAP which is going to be there. So again, 50% of my coding, whichever to support for J2EO portal also is being reduced. Okay, it's a sleek ABAP system. And previously it used to support what? Multiple databases. Now it is only HANA. So that also we have reduced it. The space for this is reducing the database based programs, everything and all, whatever we have it, it is also reduced. So at least we can say at least 60% of the code which was there in your previous ABAP is now reduced to 40% only. We have very sleek. And they're trying to depend on most of your Eclipse. So Eclipse will try to communicate with your ABAP. From there, we try to get the data from your database. Okay, so this is how it happens. Cool. Next. So what are the advantages? What are the advantages of your SAP HANA? So as you said, like, okay, one more point here. Now, when you see SAP HANA development, so here we have, so SAP HANA, this in-memory technique is not an SAP proprietary one. So that P Star, there is a company called P Star, and P Star company was having the P time as an in-memory row store database, right? They already had from years. Now SAP has bought this company, P Star company, which is a P time in-memory row store database. They had it. Now it is a proprietary part of your SAP. Now in BW Accelerator, we had the concept of column store engine, column store storage. So this in-memory row store and in-memory column store, these two collectively, they made this particular SAP HANA. This development has started from 2009, and MaxDB is for your say database storage and other things and all. Okay, so it's a backup like which you have. So mainly core is your in-memory row store and in-memory column store, right? So these two combined, so it is for OLTP as well as OLAP, both functionality will have. Next, as we tell that it is for hardware as well as software. Now hardware side, what we have, so this is your RAM. So RAM, as I told you, we can have approximately 60 TB also RAM, so that now it's boosting, right? Say for example, if you have your laptop with say 8 GB, if you double the speed of your, this one is 16 GB, always applications runs faster, right? And we have your core within CPUs. So one CPU inside, if you see, will tell the speed of the CPU depends on the cores, how many we have. So it depends on the heads and all, the frequency also is one, but second is the number of cores also is important here. So one core will have 3 caches, L1, L2, L3 cache, what I have in the in-memory calculation there. So sorry, the calculations within the memory is there within the caches. So one core will have 3 caches, L1, L2, L3. So like this, more the cores, more the processor calculations we have. So for example, you will tell dual core processor, i7 quad core processor. So like this, 8 processors, sorry, 8 cores. So like this, the more the cores you have it, yes, more the things which will be happening. Okay. So in my system, I have say 2 CPUs, they are there, and one CPU is having so 4 cores. So total I got 8 cores within the system. Okay. Say if I want to show this, I go on my PC, properties on manage. the device manager. Where is CPU1? So audit computer processor. So when you see the processor here, how many processors do you have it? So you can see how many cores you can handle here. So I have an Intel Core i7 with two processors, dual processors. So each processor is having four cores. So total 8 cores. So more the cores you have it, more the processing power for your system, right? And the RAM, if you want to find out, see here you can see this is my installed RAM is 32 GB system here. Okay, so within this one. So next, software side. So what are the benefits of HANA? So the first benefit is SAP HANA is a in-memory. As an in-memory means it is not running at the disk. The whole data, whatever we have, the enterprise data, we have it totally. It is running in your SAP. Sorry, it is running on your memory itself. So all insertion, updates, deletions, everything happens in the RAM itself. Okay. Next. So we have in-memory row store and in-memory column store databases. That is the first advantage of your SAP. Storage is in-memory row store and in-memory column store. Second, so we have compression, right? The column store data in your SAP is being compressed. Okay, so the data is compressed so that because RAM is very costly. Okay, 1 TB spending also you're finding big difficult. Now, say for example, if you have 10 TB of your enterprise data, and if compression helps you to, when it is compressed, the 10 TB is getting stored within 2 TB itself. It's very good, right? So reducing a lot of space there. Okay, so compression will reduce your cost also, as well as gives you the better performance. Two things: cost-wise also it is beneficial for us, and your data output also is very faster with the help of compression. Now I'll tell you what are the compression and what are the different types of compressions we have there. Right? Next, when you go for partitioning, right? So partitioning of the data also is a very important factor for your SAP. Now you may have multiple servers within the HANA database, right? You have multiple nodes. You have got 10 nodes or 20 nodes are there in your enterprise, but your data is not partitioned properly. Then the whole data is going to 2 nodes only or 3 nodes only, and remaining all are sitting idle. And the customer is telling that, boss, I have spent this much of money in your organization. What I was getting before, now also I'm getting the same speed. Now what goes on? Now that is a problem with our developer. Like why we are not able to get that performance is the problem with your partition. So the data is not partitioned properly. Then the whole data may go to 1 or 2 servers only, but not distributed equally, not utilized totally, right? So partitioning also is very important factor here. Okay, fine. So any idea on partitioning? HANA partitioning? Anyone done it? What are the types of partitioning we have?
There are total 2 types of partitioning. One is horizontal and another one.
One is horizontal, another is vertical.
Vertical will happens on roster, sorry, column store, and horizontal will work on roster. So HANA will support horizontal. So inside, we come to the partition level. We have 3 types of partitions. We can, sorry, 2 types of partition again. We can do it: single level and multi-level.
Mm-hmm.
Single level comes to here, it's a hash and what do you call round robin and range partition. We can able to split that.
Mm-hmm. Okay, fine. I'll just explain that. What is that? What is there in the partitioning, right? Okay. So partitioning is very important for us in order to get the best performance there. Cool. Fine. point 3 is now in BW for HANA or even your BW and HANA. So we will not have this aggregates, no more aggregates necessary. That is what SAP is telling now, right? So previously we had aggregates, right? We used to create the aggregates in your BW. So what is the benefit of what is the main purpose of your aggregate? Is like, say for example, you have some cube. So you have cube with more data, right? Very detailed data like country. Then after that, say plant and material group. Say for example, purchasing organization. Then distribution chain. Say for example, client is a storage location. Then say for example, material group. Then material, a quantity. So like this price, this amount, something like we have. So now what we are trying to do is, say for example, I have 1 million records here, right? So we have some 1 million records. Say for example, country India, then after that USA, again India, USA, like this. I have some 1 million records for the whole data. Now, for example, a customer wants the performance for country wise, say for example, then what you do, we'll take only say a mini cube here, which will have country as well as country. We try to upload this data with the help of your roll-ups, and we try to aggregate the data and how many rows we have it. So we have 2 rows only because even 1 million records are there. So here we have only 2 rows, 2 columns here because there are only 2 countries. Unique countries are 2. And what are the quantity we had? It's say for example 10. Say for example 10. This is 20 and 10. So India wise, if you see that it is 10 and 10, 20 aggregated, and US is 30. So now the detailed data, whatever is there, it will try to keep on updating. Like this 1 million records are there, then it keeps on getting, the values are getting increased, but the number of records in this, the pre-calculated values in your aggregates are less. So query, if I try to, when I try to create a query and try to go for this, instead reading this 1 million records, now this is trying to read only 2 records. So for example, it is coming within a fraction of a second. And here it was taking, say for example, 10 minutes. Say. Now, SAP tells that now no need to create this aggregate, because now when you see the data throughput of this particular, say for example, database is 100 GB per second. So 100 GB is very big, right? So millions of records per second, you can just give the calculated value and get the throughput. So if that is the power of this, then whatever the speed you used to get within, for example, 1 second, you're getting this for the query, and pre-calculate and get this using your, say for example, 10 TB and your, for example, 20 CPUs or 20 CPUs, 10 CPUs is fine. It tends at 80, so 80 cores. So 8 cores if you have it, then 80 cores. So with the speed, using increasing the RAM, before I was having 256 GB only, then it was giving me 10 minutes. If I use 10 TB now RAM, and instead of 4 CPUs, I'm using 10 to 20 CPUs, then naturally the speed increase or boost like anything. So what we are getting the speed before with that limited RAM, now I'm able to get with the HANA with the same speed with this RAM and memory. When I calculate from here, instead of this, directly when you try to aggregate the data, you're able to get the speed of data. So in memory, it tries to calculate this. The query will try to calculate over this data. and we are getting this over this database with this particular curve. We are getting within 1 second itself. So when I'm getting the same speed, that why require an aggregate. So SAP is telling, don't waste subsets of storage of data. Now, for one purpose, like country and quantity, you created one, and after that, country, plant, and quantity, you will create another aggregate. Then after that, for metal group and say, for example, plant and metal group, you'll create another aggregate. So there, what is happening is you're trying to waste the multiple storage of the same sets of data in multiple aggregates. So this is going to consume your RAM. So hard disk is fine, but when it comes to your RAM, we are trying to waste a lot of money there. So SAP tells no, not required this aggregate store. So over the direct table itself, make the queries as and when required. You get the same power output, right? So now you don't have this aggregates concept itself within your HANA with the HANA database, whatever you should. Cool. So what is second one for is previously we used to have a lot of aggregate tables being created and a lot of indexes being created, right? Index tables are also created here. But with the help of your SAP HANA, SAP tells us reduce, remove it, all these particular things, because now that is what we see that when you see the storage of the how much data we're trying to create this, how much storage we're trying to do it. So when you see this applications not running on HANA, is it was 600 GB RAM, so even more than that. So without any application, even an ID system, if you install on your hard disk, how much it is used to occupy? 600 GB it was occupied without any enterprise data. Now applications running on HANA but not optimized, right? When it is running on HANA, it is going to bring up to 118. So at least 5 times it is going to reduce this. Now applications optimized for HANA, it is 42.4 GB. And applications optimized for HANA and data aging applied, then you see that it is 8.4 GB of the space. Is it fine? So it is reduced from where is 593 and where is 8.4 GB, right? So this is how we're trying to reduce the data. For example, hard data, warm data, and cold data, we're trying to take it up. So that application, we're trying to bring it up here. Cool. Now we'll see later, like how it is. We try to optimize and what best we can do it. Yep. See. Now, one more funda in your SAP HANA is when you take it with an application server. When I take it with an application server, then most of the calculations previously in your ECC system or your BW system, we used to do all your calculations within your application server. It is maximum 70% of the calculations was done on application server. And only 20%, when you give sum, select star from sum of this quantity, then aggregation will be done in the database. But after that, any common data or any loop at ITAB you are doing, right? Then that all aggregations, application specific, you do it in your applications. But now, what you try to do is we push down the code to your database server, right? We push down the code to the database server so that instead of bringing the data from your database to your application server, we try to compile this data or execute this particular data calculations within the database itself. Okay, so this is how it looks like. Okay, so push down of the code is what the major thing happens. Mean to say that previously what was happening, we used to pull this data, whatever 1 million records are there. So this 1 million records, we used to copy this into your RAM here. And in the RAM, we used to calculate it. But now what SAP is doing is they don't want to do in the application server because we have very less RAM. And your database is having, say for example, 10 TB RAM here, right? It has got 10 TB RAM. So we don't want to bring the data into this, and we want to do it within the database itself. So whenever you request the data, it will not pull the data into this, and we're going to do it within the database RAM itself within 10 TB. So in order to do the calculations here we create a procedure. So within the procedure, the block of code is written. Okay, so this block of code is written here. This block of code is written here, and we use SQL as well as SQL script. Extension of SQL is an SQL script, which is a proprietary language of your SAP. So using these two, we'll try to calculate the logic within your database server itself instead of processing it in the application server. We don't want to bring the data here, 1 million records, we don't want to bring it, calculate again, push back to the server. No. So we want to do it directly with the database. So these procedures normally will be created, these procedures will be created in the ABAP only. And these procedures are known as AMDP procedures. What are these procedures are known as? AMDP procedures. We can create a database procedure directly here also in the database. I'll show you how to create these procedures within the database. Plus, but the procedures which are created in the application server using ABAP, and these procedures which will be created in your HANA database. The creation, the logic will be there in the ABAP only, but these are created in the HANA database. For processing your data is known as your AMDP procedure. So we call this as procedure. Got it? So this is what the push down, how we are trying to push the code which is there in the application server. I don't want to execute an application server. I want this to be executed now in the database server itself, so that it utilizes this 10 TB of RAM, not your 256 GB. I don't want to use the application server RAM. I want to use the database server RAM. So using the procedure, it will try to calculate this particular things. What's from the database, the code will be taken to your procedure, and procedure sends the results back to your database. Going through it. Cool. This is the logic protected. Okay. One more important point is avoid expensive database operations. In SAP, it will not go for insert, update. All these operations, what are happening in the column base is only insert only statements will be affected finally. How it will be there, I'll show it later. Okay. Next. So this is the core things, right? So hardware, one is your increasing your hardware to 60 TB, and CPUs, one CPU, the more the number of cores, more the parallelization, and more the number of CPUs you try to increase it, faster the calculation. Okay, cool. Next. Coming to your HANA as a whole overall architecture. So HANA database is not only for the storage of your data, right? So HANA database is not only for storing purpose like Oracle. It has got some more functionalities where it is making it very powerful so that customers are using this database for multiple purposes. That is why again HANA is becoming more popular. Next, when I come to this, see one advantage is, okay, I'll just come to layers. One is your database services. Then second is your integration services. We have processing services and application services. So these are the 4 services which are there in your HANA database. Okay, so we have 4 type of services. Now, 1, column store and row store. These are the 2 types of storages of your database. Next, we discuss like multi-core or parallelization. More the CPUs, more the cores, better the processing and parallelization, faster the calculation. One more is your advanced compression. Advanced compression. As I discussed, compression is going to reduce the space as well as reduce the cost. Fourth, you have multi-tenancy. SAP HANA supports multi-tenancy. So there are 2 types of installations of the setup, how you can do the system. So one is your single tenant and another is your multi-tenant. Previous versions like 1.x was single tenant. If you want to configure, then you need to customize it and do it. But HANA 2.0 comes as a multi-tenant system, right? It is installed as a multi-tenant. Later, if you want to increase the number of tenants, yes, we can do it. Okay. Next, because I'll not waste time more in multi-tenancy. But if you have any doubts, please you can ask so that I can explain what is this multi-tenant and your single tenant. Third, your multi-tier storage, right? So your multi-tier storage is your multi-temperature storage. So we have 3 types of data. One is your hot data, second is your warm data, third is your cold data. But still, if you see some systems like we have frozen data also. There will be 4 types. One is hot data, warm data, cold data, and frozen data. Okay, that we'll see in the your DTO concept when it comes up. I'll explain that. Next is your data modeling. So data modeling is we can see now instead of going for your data warehouse, now SAP tells that you can directly, instead of having a separate data warehouse, you can do the data warehousing operations within your HANA itself. Now, there's a major benefit, right, for me, as we have OLAP in-memory storage. So I have my data modeling capabilities within my HANA. So we'll do the modeling, right? So we'll just go from scratch and go for data modeling. Then we have open standards. Now your SAP HANA is based on C++ language. It is created in C++ language. Okay. Next, we have high availability and disaster recovery system here. So while installing your SAP HANA, you can go for scale up or scale down approach. We can say scale up and scale out. We can say it is scale up and scale out. Okay, cool. So these are the different database services what we have. So if you want to see what is a scale up and scale out, then within the course itself we should have this. Yes, this gives a idea of what is a scale up and what is a scale out. In scale up architecture, for example, you bought 4 TB license because even though you have 10 TB and you bought a license, HANA license for only 4 TB, you have to use 4 TB only. You cannot use 10 TB. Okay. So if you purchase 4 TB license, then 4 TB whole you want to utilize in one single server only, right? Then we try to install as a single instance and try to use this 4 TB in a single server. So this is known as your scale up And the second time of implementation is your server is, we can go for scale out, in which the 4 TB we try to distribute into 4 separate servers, and these are also called as nodes. Here it is a single node, but here how many nodes are there? So total 4 plus 6 nodes are there, but actual working nodes are 4 only. Got it? Or I can say, for example, you take 4 nodes only. How many nodes are effective here? 4 nodes with 1 GB, 1 GB RAM. Now in a scale-out server, we have one master server and one is your payload server. So master server will hold the data and it will control your processing for other servers. And failover is only for your backup. This is standby server will be active here. Cool. So it happens like this. Now, I told you one will be your main server. One, two, three, four, and one more is your fifth server there. Right? Just a minute. I'll take out the one. Okay. So this is known as your main server. Slave. Slave 1, slave 2, slave 3, slave 4. This is your standby. Okay. Now the main server will be having the database, core database here. All the data will be maintained my core. So I'll take it here. And say, for example, you have 2020 data. Then 2019, 2018, 2017. Right? So I can still have multiple splits. But say, for example, these are the different years of data, what I have it. Now this is my database. Okay. Now, what happens is within the slave, I have, say, for example, 1 TB RAM, and I have 4 CPUs. Same thing applies to all these things. 1 TB RAM. Because now your expenditure is more, right? You have to buy these many servers. But scale up is only one server, so that customers now they're not going for this. Wherever they have very big implementation, yes, they go for this architecture. Otherwise, 2 TB one server is good for me. Another QA 2 TB one server. Otherwise, these many nodes, you should have that many servers, and again doing a big expense. Okay. So 1 TB here. Now here, what happens is this data, whatever is, whenever it is processing it, so this will not hold the data, but this is used for your processing purpose only. This has got RAM and this has got process. It can process. Now what this will do is, This will take 2002 data, 2020 data. It will take this and put it to this. We'll see. It will be 2019 data. It used to say, for example, this one. One more year data to the server. So four data goes for 4 servers here. Fine. So the main server decides what data, which server it has to send. Now once this is done, say for example, this goes down. Say for example, this server goes down. The moment it goes down, then master will not be able to ping it. Then immediately it makes this as a main server now. Okay. So now this goes to the main server. And now what is the data here there? So 2020 data is there. Now previously it was 2019 it is sent here, and 2018 was processing here, and 2017 was processing here. Now it knows that this server, whatever the processing it has done it cannot do this now. Now it will take this data from here. Now this is lost. Now this server is totally out. We don't have nothing here. Now it will point to, it will take this, it will point to this database and supply this data to this. Now the processing will happen within the service. Okay, these are used like Hadoop, right? Map reducing, split the data and send the data to multiple servers, cheap servers, whatever is there. For computation purpose, it will be sending there. In the same way here, split the data, send to multiple nodes, process it there, and get back the data. Now, whatever the data is processed on all the nodes, the data is given, the processed data, calculated data, will be sending back to your database in the memory. So with this is the actual database, and the results will be stored in the RAM of this. The results may within the RAM. It will give the results aggregated. For example, you have M110, M110 is actual values. It will calculate as M110, M110, M120. Then it will put here M120. Then here 1 million records it is aggregated. Now it is brought to M130, say for example. Like this, from multiple servers, it has got that calculation 1 hour. Say for example, serial means what? 1 hour, 1 hour, 1 hour, 1 hour, 4 hours. But if you do parallelly, it is only 1 hour for all the things will be done. And after getting the data, I will calculate here for all these ones and give the total as M150. Now the parallel processing will be done. Okay, this is the main part of it. So you have to spend 2 extra servers, main server and standby. You have to buy, other than this particular 4 TB, you have to buy extra 2 more TB. Now, once this is up, the standby has come up, then again this will go back to your this node, and this one will go to this. This will be affecting, and it loses this data. And again, this will be copied into this 2017, right? Data goes in. Good. Cool. So that is what we have in a Bw4Hana. It explains like what is your scale up and scale out. And this is used for your standby. So even either of the server goes down, out of the 4 servers, either of the server goes down, standby will be there so that we don't lose the information, right? And the processing also will be more parallel, and you can add the nodes also later if you want to add the nodes. Now, say for example, now the requirement is how much? 4 TB only. But here, the capability of the server is 4 TB, you cannot increase more. But once you come to this, now if you want to have more servers here, then I'll try to take this standby here, right? Then after that, this leaves 2 more nodes you want to add this, and directly add the nodes here. So you got 5 and 6, 2 more nodes have been added. So tomorrow not only 6, then 8 also you can add it so that it is flexible. say for example, not 1 TB, so you had 10 TB, 10, 20, 30, 40, 50, 60. Now you brought in 60 TB. Now you want to go for 100 TB, add 2 more nodes. So 10, 10 TB, now totally you have 100 TB now. Getting it? So this is how it happens. Now if the load is more, then I can increase my standby. Now master, we have two standbys. Standby 1, standby 2. It knows that there are 2 standbys now. Okay, so there are 2 standbys. So whichever server goes down, this takes. Whichever server goes down, this takes. So like this, the same scenario will be happening. So data storage will be in main only, not none of the slave servers. It only distributes this. Okay, you may ask like if main goes off, what we should do for that? Again, we have to give a proper standard for that. Okay, main is the core. So yes, so this is how it happens, right? Okay. So I just explained you about your high availability also. Open standards. Yep. Yeah, Ravi.
So this is Navina.
Yeah.
You mean to say in the scale up we have to live with whatever we have, like 40 billion.
Single system. It is a single system. You cannot have any other nodes and all. You cannot utilize it. So what,
And
for
we cannot
example,
extend also.
you cannot extend it.
Okay.
Single node installation is there. Whatever the RAM you have it, that's it. After that, you cannot extend it. But scale up, scale out advantages later. Even though you are utilizing main server separately and standby separately, 2 things are exclusively you are using more. But advantages later, n number of nodes you want to add it. Yes, you can add it within scale out. Right. So SAP tells that when you have the requirement for only limited server, right, RAM, whatever you want to utilize it, you don't have more money or no nodes you have it, then go for scale up initially. Once that is done, then later you can change it to scale out if you want it. But then architecture has to change totally. Then again the server setup, everything, the total landscape will be changed. Okay.
But that will increase your cost also.
Yeah, increase it. But thing is, see, tomorrow you have the flexibility to increase it, right? Say, for example, now you got 2 TB, now tomorrow you got 4, increased it. Now, in your scale out, what will happen? This cost you have to put. No? Because see, analytics, we are not worried about the cost. Customer, say, for example, passport office, now there are hundreds and millions of people going and doing it. But I want to find the fraud who is there. I want to get within a minute or second. There, we have to get the data first. Or some heart operation is happening and within a second I want to get the data, getting it. So I cannot wait for hours to get the output or the symptoms and all. I cannot get it. So let the cost be there, but only thing is it has to process millions and millions of data. Then tomorrow it keeps on increasing it. Then it is required, right? So cost, yeah. So that only people who are worried about the cost, they're going for scale up for the time being. And you want performance as well as you're not worried about the cost, then go for scale out, right? So that you can extend later very easily. That's not a problem. Okay. So most major implementations, what you see now, it will be all scale up only, right? 2 TB is there, I'm using it. But over a period of time, people will go to scale out. And there 50% scale out are there and 50% we can say scale up are there. Good. Okay. Coming to multi-tenancy, you have the everyone is clear with this understanding what is multi-tenant or system or single system. Single tenant and multi-tenant. Anyone can give an idea? What is a single tenant system and what is a multi-tenant system? Because see, now when we come to Bw4Hana, we should know these things and all, right? So this should be perfect. When to the client, we cannot tell that, no, this is not known or multi-tenant is not known. No, we have to. Yes, guys. So after this, we'll take some break. 10-15 minutes break. We'll take it up. So don't, not only theoretical, we'll do the practical also. Okay, don't worry that sir, not only theoretical, we'll do 50% theoretical and 50% practical. Okay. Yep. So any idea on single tenant and multi-tenant?
Maybe holding the multiple customers' data without transparency between customers. That's
Okay.
multi-tenant.
Mm-hmm. So Dinesh
Yeah.
is what speaking. Okay.
Yeah, it was Dinesh.
Fine. So something you need to tell, right? So that it gives us some more. So from there again we can extend it and see how it happens, right? This is what we go for: scale up and scale out. Say, for example, customer is having only one system, right? So here, single system is your server, and so what is happening is I have 20 TB here. What is the RAM size? Much. Now here it is 20 TB of RAM. So 20 TB you want to consume in one single server only, and the whole data, whatever you want to hold, you got the whole 20 TB of data and put in the RAM itself and start computing here in a single system. So this is what we call it as a scale up. Say for example, when I go for scale out, this is your scale out. Say for example, I want to use say 10 systems or with 2 TB RAM. I can, that is also fine for me. Or say for example, say 5 fours are 10, right? So 4 TB, 5 systems also good for me. So like this you can just put on it. So this is all your scale out. So here extending this more RAM after 20 TB, I cannot do anything. That's all. I have to raise my hands. Done. 20 is my whole capacity. No customer cannot do anything. But within this scale out architecture, yes, even 20 is there. You can go to 40, you can go to 60, you can go to 100. Not a problem at all. Right? Okay, so this is understood, and we go for single tenant and multi-tenant. Because when you log into your HANA database, when I go for my, for example, and I try to go for add a system, the first thing it is going to ask whether you are going to log in into that single tenant or you're going to use a multi-tenant. If it is a multi-tenant, what is your multi-tenant database? Right? What is your multi-tenant database? Just that. Okay. So now what I try to do is, say for example, you got your piece of land. This is your piece of land, right? I think most of you might have bought of this land in Bangalore, na? So how much? What is the scale? What you bought it? 50, 60, 50, 60. So regularly matter, right? So 1,500 square feet you bought. 3,000.
So is it something like
30.
multiple DB instances in one schema kind of stuff?
I'll tell you. I'll just a little bit explain. No worries. Right? So you bought 50 by 30, 1,500 square feet. You bought this piece of land. And now in this piece of land, what you want to do is you want to build a villa, right? You want to have a villa. So your house number will be what? Only one, right? So your house number will be what? House number will be, address number will be, for example, 123. Only single. So single person is going to consume this whole space. So villa is only for one person. Now that is what we call as a single tenant. But with the same space, right? You want to build one apartment. Say for example, 5 floors into 2, right? 10. So total 10 floors you want to have. So now each floor, each house will have a separate address. So this is house number 1. Then say for example 100. Right? Another apartment number is for example flat number 101, flat number 102. So like this, I have multiple flats. We're splitting this space, right? We're splitting this space into multiple tenants. So 10 splits I've done it. Now each space, one little space, he is the owner of this. He is the tenant. He is living in this. He is for rent. Now this guy, he is the tenant. This space is owned by this. This whole space is owned by this. So here in HANA also, now whenever you go for this, we'll give HDB is one space. Total system space is one taken by one. And if you have another one, I'll give another HDB one, HDB2. Right? So the instance number and the DB number, DB name, this is HDB2. It's a separate address what you try to give it up. So it is a three-letter ID. So it is HDB or HD2, HD3, HD4. Like this, I'll create it. Now this particular space is owned by one tenant. Now this will be useful where, for example, cloud platform is there. Now SAP is hosting some cloud. What he wants to do for Wipro, they want one separate space where others cannot enter it. Then we tell no problem, sir. What you can have is we have the security and other things and all. So your space is reserved for you. Now you can log in into this particular ID and this particular tenant name. Now this is your space. Now this is your space. Now this guy has got a different space. RAM, the server, processor, resources, everything is same. But only thing is how much RAM you want it, he will increase it. That is the flexibility of a cloud. Now he wants more RAM, then the whole space of this will be given to this guy. Okay. Now he wants more RAM, less RAM, then okay, you take this much RAM only. So like this, the whole space I can split into multiple. He will have its own database, own schemas. Now this he cannot talk to this. See, multi-tenant also you can have that security. We can just keep it, but mostly tenant to tenant they won't make any communication. Got it? So whenever HP is coming, okay, HP, how much space you wanted? Okay, you want this much space, fine. What I will do is, you take this ID, HD3, and this is your instance number. Now this whole space, you can utilize it and pay this much every month. This is how we do. This becomes a business where I can have this much RAM. So all the whole server will be running on how much CPU. The RAM total is, for example, 100 TB is there. Right? So 100 TB, 10 TB, I'm giving to one tenant. But the server capacity here is this. So what I will do, it is not one single server, it is a scale out. See, well, installation, I will tell it is a multi-tenant. But this all data will be there, will be distributed to multi-tenants. So how many servers are there? 20 servers are there. So the whole data will be put into multi-nodes. It will be sent to multiple nodes for processing. But the technique is different. Storage technique is different. Okay. Now, one more benefit is normally what company does is, if you're not going in a business mentality, then in an organizations people will do like this. For example, I have this much big server, and you have 3 tenants created. This is one tenant, this is another tenant, this is another tenant, 3 tenants created. And I have, say, for example, 2 TB, 2 TB, 2 TB. Now they have 6 TB in the server. Now this is tenant 1, tenant 2, and tenant 3. So my applications, when I'm using SAP BW, I'll use this tenant. And I'm using SAP CRM. So I want an individual database as well as individual system, right? So then I'll take this as a tenant. And SAP ECC, I can just install it in this tenant. So I can use for multiple purposes. How we want to do it, that is also fine for me. So when you see in an organization, the server name will be same, the host name will be same. For example, here it is HANA DB2 or HTTP :/wdf lbmt 7211 is your server name. Now for all these clients, the server name is same, but his tenant ID and your instance number are different. Getting it? While install itself, I'll tell what is the database system name, HDB1 or DB1, and instance is 0100. I can give this as DB2 and give this as 11. So 01 is not coming, so I'm taking 11. And this is DB3. And this is 12. This is 10. So like this, I can give the instance number and system ID. Yeah. Hello?
Hi Ravindra, one quick question around here.
Mm-hmm.
Suppose take the number of line of business. DB1 is one line of business and DB2 is another line of business.
Mm-hmm.
Suppose in line of business LOB1, if I did some customization,
Mm-hmm.
how it will be like integrate or it's a customization to impact the second line of business in this scenario. Can you explain me that?
Last point, I'm not able to clear. The voice is very low.
Here, consider DB1 as a line of business 1 and consider second one is line of business 2.
Mm-hmm.
Suppose in line of business 1, I did some customization and after that I want to integrate with a line of business like a DB2. So
Mm-hmm.
how it will be impact or else customization is very flexible or not? Can you give me some glance on this?
I mean to say, this all servers will be independent, right? So what are the storage, what you have? Now, customization mean to say what type of customization? Is it an database customization or program customization? How is it like? Say for example, I have this is my DB, right? So this is, I will have my own databases here, own schemas here. And this will be again, it's a separate here. And this will be a separate schemas here. Now, when you're trying to do any customization here in this DB, this is individual to this only. This will not affect this one, right? So your line of business is this. Whatever you do the customization, whatever you do it, it is within the system only. Okay. So if you want to increase the RAM of this, I can do it. Then I will go for SAP HANA system DB, and I can increase the RAM of this particular server. For example, I want to make this as 4 TB now. Okay. If you have the RAM, I can just customize it. So the customization will be based on your separate tenant. So you can increase, decrease, you can take a backup of this separately. Okay. Now, for example, I want to take a backup of this separate tenant backup can be done. So it is not going to make any changes to this. For example, I want to take a backup of DB1 only. So take a backup of DB2. So if you do any customization here, it is totally independent. It doesn't impact the other tenant there. Is it fine? But only thing is, if you shut down the system, then what will happen is the whole services of this will be down. So resources utilization will be there in the single system or multiple nodes, whatever it is. Master is down means what will happen? All systems are down. So whenever you restart it, again they will be working on individual systems. But customization, development, everything is separate to each line of business. It will not be linked with any other database. Each tenant is individual one. Is it fine?
Okay.
Yeah. Okay. So this is your single tenant and multi-tenant architecture. So I covered whole database services. These are very important for us. These are the core things what we should understand. Okay. Now coming to SAP HANA integration services. How we are going to get the data into your HANA. I think we'll take a small break. Now it is 11:40. So we'll be back by 11:50.
Yes, Ravindra, we can do.
It takes at least 10 minutes break. So at least 5-10 minutes we'll take a break, man. Otherwise, when we start talking also will make my throat down, right?
Yes.
Okay, chalo.
Thank you.
We'll be back by 11:50, right?
150. Yes.
Okay. Okay, so continuing up. So we have one more services, so what we call it as an integration services, right? Now within the integration services, we have data virtualization, then we have ETL and your replication. It's not ELT, it is ETL and your then after that replication. Then we have streaming of the data, right? We have streaming of data, and we have Hadoop integration. Then we have a remote data sync. So there are different softwares for integrating this whole functionality. So we have data virtualization. We call this as smart data access. SDA is used for data virtualization, and SDI also comes into this, but it comes with ETL category also. Second, say virtualization comes like this. So here, this is how your integration services will look like. In the database, say for example, your source is any source, like we have Oracle, SQL Server, right? So multiple databases you have. Now from Oracle database, you want to pull 1 million records from Oracle sales data into your SAP HANA sales data. Annotations, let's see here. So here we have some 1 million records are there in this, and you want to pull this data into this database as 1 million. Actually, I had that pen tab, but I just kept in Bangalore. I'm still stuck up in my hometown in Vijayawada itself, so that all my resources are there in Bangalore itself, right? So that is how we do the lockdown. Otherwise, pen tab is there. It is very really good for explaining and writing all the things, and it was really fit well timing after you do this. Okay. So when you do the ETL, so what is ETL? Extract, transform, and load the data. Okay. So extract, transform, and load the data. So when there are more number of records, yes, we try to use this. So we have the one of the simple system where we try to use it is your SLT. SAP HANA, we use SLT as the first ETL which you'll be using it. And one more SLT which will be used is your BODS. So one more your ETL is your BODS. So the difference between the extraction is SLT supports real-time extraction, whereas BODS goes for scheduled extraction. Like BW, we try to schedule the data every 1 hour, whatever. When you schedule, you put your job and schedule it, then the data is extracted. But SLT, no need to schedule it. The moment the data is created in your source system, it is automatically created in your HANA system. The same record within a second, you will see this in your target system, HANA. If you modify it, there also you see a modified record. If you delete it, there also you see a deleted record. But in BW, we had right yellow cockpit, then after that delta table, then this table, that tables. No, nothing is required here. Very simple. And this is based on your trigger mechanism. SLT works on triggers. And BODS is like Informatica. So this has got a separate architecture, right? It has got an replication engine, so ETL engine, which is going to be there inside this. Okay, there are engines within this. And what it does, it connects to your source and target and try to pull the data. So these two are the best ETLs what we have. Okay, so SLT and BODS. Now, second type of service, what we have in this, you don't want to pull the data, but it is a very time critical data. For example, to the second the data changes. For example, you have your stock, company stocks are there. Now you want to see at 10 o'clock, 10:05, 10:06. So every second you want to refresh and see what is the stock. But ETL you are scheduled for 1 hour, then up to 1 hour the data is not coming. So whenever you want to have the data immediately refreshed, then better you go for your smart data access. What is the connector? SDA, smart data access. What it does is from your source, right? From your source, through smart data access, it goes into your table. Now this table we call it as a virtual table. It's not a physical table. In ETLs, we want to store the data physically, so we use the physical data here. But in smart data access, it always uses a virtual table. And top of the virtual table, then we can go to your engine, database engine, and you can go to your SAP HANA Studio or directly your reporting tools like Tableau. Then after that, say for example, you got Power BI, then after that, or business objects, web intelligence, whatever is there, you can connect directly to the systems. Get it? So whenever you refresh the data, it goes to the engine goes to a virtual table will directly link to your database table, get the data into your memory and display it. The moment you close the report, the memory is lost. Or whenever you refresh it, you get the fresh copy of the data into the virtual table. Okay, so this is how it functions. Okay. Now, as I told you, one is your SLT, another is your BODS. Then after that, we got Sybase replication server, which uses a log-based replication. And there is one more interface called SDI, Smart Data Integration. That is known as SDI. Smart Data Integration. So this is equal to your SDA, but only thing is you can pull the data into the target, not virtual. But virtual table will be created for the smart data access. Virtual table will be created. Again, there will be a physical table also created, so that the first data will come into virtual. After that, it will put the data into your physical data. And the smart data access supports Delta. Okay, this smart data integration, this supports Delta. Whereas smart data access doesn't support Delta. This is the difference what you get. SDA doesn't support Delta, but SDI supports Delta as well as real time. Okay, cool. Now, SDI uses log-based replication. It is not trigger-based replication. It is a log-based replication. Sybase replication server also uses log-based replication. SDA also uses log-based replication. Okay. Fine. Next, in BODS, actually, BO data services, SAP BODS. So we had two main core components in this, that is known as SAP data integrator plus SAP TQ, data quality. BODS, we can say DS is equal to DA plus DQ. Data services is made of data integrator and data quality. Now, SAP BODS was a separate license. Okay, this is separate software and this is a separate license. And we used to pull the data from your sources using your BODS and put it to the database. If your data is very dirty, very huge volumes of data, then we have to go for BODS. There are complicated cleansings which are there in this very dirty data, then we go for BODS. But the data is very less, the data is very refined, right? Then we can go for SLT. SLT is not a heavyweight system, it's a lightweight system, right? So, but you will get a real-time data. Immediate data will be there because immediate data means always it should be a very lightweight only, not heavyweight. But BODS, heavyweight, even you have some lakhs of records, pull it, transform it, cleanse it, push into the target. So these functionalities, what we had, your BODS called SAP BODI data integrator and data quality. They are separate components here. But now SAP has made these two components within the HANA itself. No need to have separate data services. Directly, they made the functionality of DI and DQ functions within the HANA only. And this tool is known as EAM, Enterprise Information Management. EAM is known as Enterprise Information Management. So EAM consists of two parts now. One is your SDI plus SDQ. So EAM consists of two things here. EAM has got two things. One is your SDI. Okay, we've got two things. One is your smart data integrator. And they renamed this. So SDI plus SDQ is equal to EAM. So BODS will not be installed in the HANA system. It is not a part of the HANA. It is outside the HANA. So BODS will connect to the source system and BODS will connect to the target system. And schedule a job, it takes the data from the system, cleans it in the BODS server and pushes to the target. But in the EAM, what will happen is, here we need to pull the data into this BODS HANA server. Directly before pulling, you can cleanse it and send to the system. Okay, so this is how it happens here. So now, no need to buy the BODS. You can directly do the functionality of data integrator and data quality within the HANA server itself. Good. So this is what we call it as an EAM tool. Good. Now again, so we for streaming data. Now what is a streaming data? Say for example, when you see streaming, so normally when you see the normal reports, so you'll have January report is like this. Feb report is this. For example, February revenues. Now when February is completed, then only the data will be totally filled up. Now again, March, it is gone like this. So this is statistical reporting what we try to do. But when you see the streaming report, say like normally when you see the stocks, so like your say in the hospitals you will see, right? It is always streaming. The data is always streaming like this. Every second it keeps on showing you what is the status of your stock rate and all. So every second the data keeps on coming to your server and this displays in the graph. So this type of data representation in the graphs is known as your streaming graphs and all. Okay, so the data should be streaming. Every second there will be some hundreds of say packets which will be coming within that. So that will be represented as a data representing the graph. So this can be like your vehicle movement, your transport is moving and you want to track this, right? So or the satellite moving very faster. Now we can tell that your movement of your vehicle you can see in your phones also. But there will be some stucks what you find out. But if it's a satellite, what happens? Going very faster. So even that particular speed, I want to just capture and see how it is happening. Right? So then we want a heavy processing system, which is what we can use it on. So for that, we have a streaming server, the ESP server, event streaming server will be there within the HANA server itself. So that is used for your streaming data, right? So there is this. Okay. So in the data integration and quality, so we have data virtualization. So data virtualization is smart data access, then smart data integrator, then ETL we have got in order to extract the data and pull and cleanse and pull it. So we got SLT and we got site-based application server and SDA also. We can pull the data with that. And we have got EAM tool in order to pull the data, cleanse it, and push into this smart data integrator and smart data quality. EAM as well. Fine. Then after that, one more is your data streaming. What we have got it, that is not there in the slide. So data one. So what we got is your ESP server, event streaming server for that. And for Hadoop, because structured data and unstructured data. So your social media images, then after that mails, these that and all. So your, say for example, PDF files. So from there you want to find out some secret information, this, that and all. So what happens is that is all your unstructured data. For that, Hadoop is very good. But structured data, where all the data is stored in your database table, sales data, financial data, for this structure, HANA is very good for processing it. Okay.
Ravindra, I have one question. So you are saying EIM tools, so those will be the part of SAP HANA system, or that will be a separate tools?
No, it is a part of the SAP HANA.
So all we have is only transformations in the HANA system.
In the HANA
itself.
system itself, yes.
Okay.
Now we can transform the data using your EIM, whatever is there, but it's a separate license actually. It's a depends on the license whether you're going to use that add-on or not. That depends upon.
So will you be covering those transformations here?
Yes, I'll show it.
Sure.
I'll give it. Right.
Okay, thanks.
So we'll be seeing that. So Hadoop is good for unstructured data, and HANA will be used for your processing the structured data. And we have remote data sync. So this is mainly used for, there is separate software for remote data sync. This is mainly used for people who are in CRM, where customers are outside or long distance between your server and they want to take some orders, right? So what they can do is, even they're not connected to the server, they can just take the orders within their laptops or iPads, whatever it is, within small mini database itself. Then after that, when they come to your server, there is a sync server within the HANA, so that it gets replicated. All the orders from different customers will be replicated and again distributed to all the people, telling that, okay, this is the orders what you have given it. Now you got to some customer, right? And the same customer, he should not again create it. So master data should be same. So all the customer from all the CRM people will be taken, synchronized master data management like will be done, and that customer database will be updated in all the customers again. So that is the functionality of your remote data sync. Cool. Next, we have advanced analytic processing. That is your spatial engine. So we have in HANA not only your data processing engine, but we have got the special engines here, that what you call it as a spatial engine. Now for processing your data, I'll just show you. For processing your data, we have join engine. For call-up store, we have join engine, collab engine, and calculation engine. Depends on model, what type of model we are using it, that particular engine will be involved. If it is row store, we have a row store engine. Now, on top of this, we have an SQL optimizer. So SQL optimizer, always when you view an SQL optimizer, when it fetches, then it will see what is the best path, what is the least cost it is going to utilize, that it will suggest and give the output to you. That is inbuilt in automatically, it will happen, right? So SQL optimizer. So mainly SAP HANA, now you can see that it's normal databases just have your database, and after that a normal SQL optimizer will be there. But in your SAP HANA, what we have is, so it is used for OLTP as well as OLAP purpose. And for complex calculations, we want one calculation engine to be there. So we have three types of engines for your data retrievals, insertions, extractions, whatever it is. Okay. So these engines are there for modeling purpose as well as for your OLTP. Plus, we have still special engines, like we have a SPATL engine. Okay. So going to this, let me do some presentation. So there's again a separate course for advanced modeling in HANA. So normally for HANA we have 300 course, 100 is there, 301 is advanced modeling within that. Okay, so there are different courses what we take for SAP. Right? So here we got all libraries, predictive analysis libraries. That is what I'll come to next. I'll explain this later. Second is SPATL, right? Just talking about your SPATL engine. So this is used by public sectors and utilities, oil and gas people, as well as retail and customer packing goods people. It will be used up. And mainly we have some different types of data for this. OpenStreetMap here, then ESRI. There are some different platforms. Now over the data, now you want to show this data like this. Over your Google map, you want to see, or from my store, I will give my SQL, but SQL when I give it, I cannot give with the address. Right, from Bangalore 10 kilometers, I cannot give. I will tell from my latitude and longitude. So the data also will be stored in latitude and longitude. Further, the data type also should be supported for SPATL. So HANA supports that. Right, no need to go for a special software and separate license for this. But at least we have this SPATL situation. All right. So from there, your enterprise data and SPATL data. So we have SPATL engine within the HANA database. Not only your database engines, but we have got your SPATL engine. So we can show like this, then geospatial processing visualization, GIS accelerations. Okay. So you can show data like this. So we'll be having different data types there, storing the data as a point, latitude and longitude. If you tell, this will be the point where it is stored. Now, if you want to show like a road or say a small river is flowing like this, then you can show with the help of lines, right? That's what happens. And you want to cover an area, then you go for your polygon. So like this, we have different data types, how we want to store it. Longitude, and latitude, longitude at this point. Then automatically, when you tell line string data type, then you put a line also for this particular 3 latitudes and longitudes. Okay. So the data type, what we'll be storing in HANA database, like string character we have, right? Number, amount, quantity, whatever you have. So here we have your ST geometry, and it has got again different types of data, sub data here, like ST point, I told you, right? Point, line string, polygon, circular string. So this is what we have the data there. So point, line string, then that circular string you want to display like this, and multi-polygon you want to have it. This is all data types, what we try to put this into the system. And the statement will be like this: create column table, SPATL data table. Integer is fine for us. ID for the location is, store name is fine. Then where is this that particular store? Then it is the data type, I'll give it as ST underscore point. Now within the point, whether it is a latitude and longitude or it should be multiple geometric circles or polygons and all, we need to specify. So these two are spatial data types. And the formats of data also is there for geometry. Fine, that should be fine, I think, right? Okay, the values, right? Point, latitude, longitude. We try to specify this. In the polygon, we have again specified latitude, longitude, multiple points. We try to specify. This is how we try to create a table, and after that, how we'll try to insert the data inside this. Cool. So one is that representation, and another is we have graph data. So this is for your geos pattern, right? Definitely looks like this. So what area you're going to cover, or plants where you have some good revenues, less revenues, or depends on the raw stock, how much you have it. So whatever is that, you can just go for heat maps, right? So whenever you click this, automatically it show the location. You can scroll, slide, and do all the things in that, right? Now we have some graph engine inside the HANA. So mainly we have a graph which each object is known as vertex, and the relationship between each, because this is a vertex, this is a vertex, this is a vertex. Now what is the relationship between these two? That we are going to define the relationship between each vertex. So each relationship is known as edge. It is nothing but vertexes and edges within the graph. Okay. So this is a relationship table, what you try to do, and we try to give the data relationships also with this. See how many distinct values, how many vertexes we have it, right? Now how many edges we have it. So this is also small graph taxonomy will be there inside this. And finally, you have the links. We can tell that from here to here, what is the time we'll have, what is the distance between this. And if I have this one, how many things are connected to me. So for example, I want to send this from here to here, then what is the best route to take it? Whether I can take from here to here, or I can take from here to here also, right? So I don't like what are the different routes and what best it can be done. Everything it will try to give with the help of your. We can do some query with this. Like we'll use strongly connected components. What are the neighborhood searches, grouping of the components, filtering, so everything we can do. Okay, so the weightages can be given here and execute. You get the data output there. Give the list telling that okay. So from this to this, you got this much weight. Okay, which are linked to all the things which show graphically. So this type of engine is known as your graph engine. Okay, strongly connected components of this. Okay. So one is your graph engine for finding the relationships between your entities, and one more is, so you're using spatial engine, graph engine, and we have your predictive analysis engine. Okay, for predictive analysis, we have a separate engine here. And for text processing, we have a preprocessor. For text processing, we have a preprocessor. So preprocessor engine is again separate for this. And so mainly, say for example, when you go for your preprocessors, text processing, so mainly it is, say for example, whether you want to use your exact data or you can see linguistic also. For that we have a fuzzy search engine, which is there in the RAM. What we call it is a full text search. Now say for example, when you go for your Google, right? So you try to search for a word, but even though it is wrong, what will happen? It will try to give some fault tolerant search. Means to say equivalent to that nearby words, whatever it is equivalent to that, you try to. But in SQL, when you try use a like statement and star, even that is not matching, it tells there is no data found at all. But Google search is not like that. You give a word, then some data will come. Whatever is there, you type anything, the data always throws something which is going to happen. So such what we call it is a fault tolerant search. And search again, it supports multiple MIME types. You can search for your PDFs, MS Office, plain data text, HTML, XML, multiple texts. It supports different data types and multiple languages also. 32 languages are supported. You want to search in Chinese, you want to search in German, English, that also is good for us. So in your whole database, you want to find some complaints with gearbox sound, gearbox noise is coming. So I want to search for the database and find out what in this particular model, gearbox sound, how many database records are there from it. So that I can search only that related. So I'm instead of gearbox, I'm putting a GAR, I'm putting GAR box. Then still you'll get the word which is going to happen. Okay. So that is done with the help of your fuzzy search. We have a search called fuzzy search. For that we use a statement called where contains. All right. So what is a field and what is the word you're looking for. Okay. So then wherever it finds it, you can just even highlight it and display it. That is also fine. And it is a little bit linguistic also. Say for example, you search for a word called search, then it may find some word with searched also, searches also, searching also. So grammatically also it will try to see. It is not only search only exactly has to be there. Related to this, it can go for linguistic. Okay. That is one advantage with this, and we have a fuzzy score. Fuzzy search engine is there within your HANA database. Even in ABAP HANA also we use these fuzzy search engines. Okay. So when I go for fuzzy search, you're trying to search for example, Dan Dare. And here in fuzzy search, we always give the score. We can set the score so that how strict the search should be there. If it should be an one-to-one search, exact search, then you have to give a score of 1. Right? If 50% of some particular data is matching, then it is you can give it as 0.5. I've given 0.9, little bit reduced it. Now Dan Dare is there, but you've given us Don Dare. So at least only one is missing, right? So at least we'll give it as 0.1 such is there. So this will be coming as well as both the data will be coming out. In 0.9, 2 records will come. In 1.0, it will come only 1 record. In this, 2 records. But if you give 0.5, 0.6, here is a Daniel Dyer. Nothing is matching here. Daniel means Dan is coming, but it's not exactly equal to this. And DA here is there. This is not there, but still we'll get the word. Cool. See the advantages. It will search from your PDFs, from your Excel files, these things. Plus it will go for your multilingual search in multiple languages. It is able to search by grammatically also, as well as how strict it should be there. Right? You can see this with the help of fuzzy search score. And even you don't give a score, then after searching it will give you, okay, this was the score for this. This many records has got, this is a score, okay, this is 0.8, 0.7, this is what the score rate what it will be getting. Right. See here, select score from this, from training. So select score means you give the score ID for each and everything where contains your street, and you want to find for this, and you're telling that after that you have to give fuzzy 0.5, means you're setting that how strict this particular search should be there. So it will be from 0.0 to 0.1. So this is a rate for this. So this is one, and so that is one important thing. And we have a streaming analytics, that as I told you, the TSP server. So we have a streaming engine. Then we have series data. So continuously some millions of records. So your meter is running for hours and hours, right? Even there is small distortion for a particular second. So such a series data, whenever you want to store in the data as well as find where, how it is happening and all. So you can find with the help of your series data. And we have a business functions. So you can create your own functions with the help of C++ libraries. And they are predefined functions for your prediction purpose. And these functions are known as AFL functions. What they are known as AFL. So there are AFL libraries that are provided by SAP. So AFL means application, function, library. Now AFL consists of two parts. One is your PAL, all function, plus BFL. AFL is equal to, I can say, is equal to PAL plus BFL. So PAL is for predictive analysis libraries. And BFL is your business function library. Now, when you see this predictive analysis libraries is majorly used for your uh, using your algorithms, mainly your machine learning. When you see right nowadays, this is a hot kick in the market. Right? Machine learning will use their algorithms in order to find the predictive values. So for that, we have your machine learning. All the algorithms which are there in the machine learning is already provided. It's general to the market. Even Python has got more. There are hundreds and thousands of libraries, but we have got the libraries which are used standard. Okay. Next, even R also. Normally, R language is also which is normally uses these libraries. Predictive analysis. It's a statistical libraries what it can. And business function libraries, they are functional libraries. This is financial libraries. It's mainly used for finance. Cool. So predictive analysis libraries are for prediction purpose, and I'll show you what are these, where it is installed, how it is. We'll try to do something, but just giving some how to use. And your stored procedures normally supports R language. You want to do some, you want to utilize your R code, then you can use your R language. People who love R language, yes, they can use it. Now, stored procedures supports R language, SQL script, and L language. Also never used this L language, but there is a language. So a stored procedure supports three types of languages. One is your R language, SQL script, and L language. So default is SQL script. Now, what is happening is we have deep learning now, right? So we have now one more thing is what we have deep learning. So deep learning, and also what will happen is deep learning will say for a predictive analysis, we have to provide the data to the computer. Means we have to train them, right? You need to train the computer, telling that if these are the parameters, then for example, you tell that apple is there, right? How it should be, round, red in color, and you tell the shape should be like this, everything, and you try to load into the system that there are the 100 types of apples will be like this. Getting it? Then whenever you feed an apple to this, then it will take the database. Already there are some trained data, right? Taking this 100 apples, color these properties with different dimensions, and what you are given this, it will recognize whether it is an apple or it's a guava. If it is green in color, it will The algorithm will tell it's taking these parameters, this is a Apple upload. So machine learning will tell to the system, you have to feed to the system before in hand, telling that dimensions, parameters, and as well as thousands and thousands of Apple sizes and different things you give to the system. And it understands that, okay, this apples, okay, it looks like this for this 100 things, these are properties. But deep learning is not like that. You don't tell to the system, no need to feed to the system. By seeing that particular object itself, you'll categorize that, okay, this is an apple, this is an guava. So it has to detect by its own. So for that, for every dimension, it has to calculate those dimensions automatically and tell that, okay, this is an apple. So nowadays, what you see, face recognition. What is happening? The camera, it is going to read your face like this and automatically tell that, okay, this is Ravindra, this is the guy. And you might have seen, right, in the app also, we have got Google's one. You just take a screenshot, you directly take your camera and just put a lens and or whatever. You show some what type of flower it is and automatically tell that this is a flower and all the properties, your store, whatever it is, you try to give it. So bottle means it will recognize this is a bottle. Now, these are how it is going to come. So it is automatically the system is learning from telling that it is a deep learning. And it requires high processing servers, RAM, everything and all. And it requires some algorithms for that also. So that is done by your TensorFlow. Now, SAP HANA is integrated with TensorFlow. There is a software called TensorFlow. Now, SAP HANA is not actually having this software, but HANA is integrated with TensorFlow. Whatever the data you have in the database, it will send to the TensorFlow, and we get the results back to this. Okay. Now, next. So that is good with your advanced analytic processing. Next, in SAP HANA, so whenever you see your HANA cockpit or DBA cockpit, now these are all your web pages only. So who is going to process these web pages? So the processing of web pages, when you try to see that, say for example, when I connect to the system, connect to the system. So what is this? This is a web page, right? So these web pages use what? HTTP. Okay, this web page uses HTTP. And in the HTTP, people are developing some applications directly here. You can see here. And this is a web page. And it is directly talking to this. For example, I want to create one delivery unit within this. Right? The delivery unit is what I'm going to create it. Or I want to do some transportation. So I do some transportation. Now this is nothing but you're using your HTTP here, right? HTTP yes or HTTP whatever it is. So to your HANA, right? To the HANA database, when you're using this. So when you're trying to use this HANA database, now I have some HTML, and HTML communicates to your server with the help of HTTP. The protocol we use is HTTP. When you're using HTTP means you should have some web server in your HANA also, right? Now this web server which is installed in your HANA server is known as XSA, XS. So previous versions in HANA 1.x, we had a web server, default web server, which is installed, is known as XS server. So that is known as Extended Application Services. Known as Extended Application Services. Now, in XS 2.0, so we have one more server called XSA, means Extended Application Services Advanced. Extended Application Service Advanced Services. This engine we call it as an XSA engine. Now, XS was supporting only XSJS. We call this languages XSJS is only JavaScript. Supports only JavaScript. But now XSA, now this is obsolete. Now SAP is telling don't use anymore. This is done. Gone. XS is obsolete. We have to use now only XSA. Now one more thing is this supports XSJS. Right? This supports XS JavaScript also. Now this supports Python. This supports Java directly. If Java is there, most of the applications, whatever you want it has J2 engine also directly. Okay, it supports Java also, and it supports Node.js, and it supports Ruby. And it supports Perl, right? C++. Now, these many languages it supports. Still more also it has got it, but some of the languages like JavaScript, Python. Python is there also working. It's universal, right? It can do n number of applications. Whatever you want to do it, you can just do it. So Python is there, then Java is there, Node.js is there, Ruby is there, Perl is there, right? C++. So these are languages are supported. Now, for developing the applications in your through XSA, now we have a tool called Web IDE. Now HANA modeling, whatever you do it now, so will be done in the tool called Web IDE. Web IDE interface. This Web IDE will be connecting to your XSA server, extended XSA, extended application services. And the benefit of this particular XSA is it uses the concept of cloud foundry. Now here XSA uses what concept? Cloud foundry. You need to say whatever the development you've done in on-premise, tomorrow you can take out the same script, code, objects, everything, you can put in the cloud. And in the cloud, for example, you've got Amazon, right? AWS is there, or Azure. It will be anything. It uses any, for example, Google Cloud. So anything like whatever you wanted. On SAP also, SAP has got its own cloud. Okay, it's Neo Cloud what we have. So SAP Cloud, whatever it is, whichever cloud you wanted, So the same thing can run there without any dependency. The main thing is, normally in the Cloud Foundry concept, we don't have any dependency with other components. It is individual. Tomorrow you want to put this and migrate into some other thing, just put it directly here. Put it into AWS. Wherever you want to deploy it, easily deployable. Yeah. So Cloud Foundry itself is a concept. Okay. So Cloud Foundry is a main database. Okay. One more doubt was there from Mahin. 11 o'clock. Storage is still sitting on main database. All years of data sitting on main database and not on separate slaves. Yeah, will be sitting not on slaves. Slaves it will not store any data. So what we are asking, right? When I go on for scale out, so data will not store in slaves at all. It is only for computation purpose only, calculation purpose only. So the whole data will be there in one server only. Okay. Now, Vinay. So what is your Cloud Foundry? So as I told you, the funda of your Cloud Foundry is, see, practically if I tell you, in your system, what you have done previously, if you want to create a table, you'll give a create statement, right? Create table, EMP table. Okay. So then after that, you give some field names like EMP ID and department like this. When you create the table, you execute a statement. Then after that, the database table is created here physically with some data. The database table is created here. Now, when you do a transportation, then you're not going to transport the code, right? What you do it, you try to take this table object here and try to put it here, right? The table object wise, you will try to transport it and put it here into the production, wherever it is, production or whatever the server you want to do it, you have to do object level. But here, what happens is we try to take this particular code and put in a file here. Cloud Foundry, what you try to do is you try to put this in every development, even schema creation, your model creation, your table creation, everything will be done in the file only. Only thing is, what we'll do is we'll take this file and deploy this file from here. So creation of the table also is done with the help of file only. And take this file and put this in Azure and copy this, execute this one, well, deploy this file. It will create this table here. So deployment is not with the objects, it is with the help of files. So we try to do directly with the file systems. And the concept is, once you have created it, it should be independent and deployable easily in any platform, right? So it's not a repository. It is not a repository. Cloud Foundry is a concept where we are telling that it is independent and we try to store the data. We try to create in the form of files and take these files and try to deploy this in another server so that the objects are created from the scratch in that particular point only. Right. So in Cloud Foundry, what we'll do is we'll create a project. Under the project, we'll create one container. So it is going to go for the concept called container concept. We'll go for, so we'll create one container. In Cloud Foundry, they tell that I create one container. It is like a repository for you. Now inside the container, all this tables, fields, whatever you do it, that again with the help of generation, that it has to generate the data dynamically. Okay, so there is a runtime engine here. In the HANA, now what is happening is XSA will provide the runtime. Let it be Java file or your Perl or whatever it will support multiple runtimes. Now you should have a file here. In the code you written, right? This code, whatever you written, you store within a file here now. Now this file, you just created this file. Now what you will do, you will tell please deploy it. Not create it, you deploy in the runtime engine. And runtime will create this inside your container only. Getting it? A table is created here. Now this is your HANA database. So there a table is created with the help of this file, and the runtime engine is there here, and your table is created. In the same way, in your cloud AWS also, what they will have, these people will have the runtime. They have AWS also has got a runtime, as well as like Java runtime, then Ruby runtime, Python runtime. These are all libraries, are all the runtimes engines are already there here. So that you have that model, right? SaaS model, then PaaS model, infrastructure as a service, service as a service.
So
Then they provide only the infrastructure, runtime, only database, only hardware. That depends on what type of resources you can utilize. So they provide the runtime, and only thing is you take the file and you tell deploy. Right now, using the runtime, there the table will be created here. So EMP table will be created. Okay. So it will first create a container. The same container will be created here also, and it will be deployed. So like this it happens. Okay. Yeah. You're asking some doubt. Hello. So we'll see that normally that is a separate again concept which will be using it, and in this XSA we'll be using one is your cloud foundry concept, which is a concept, as well as in this cloud foundry we'll use a container, and the objects will not be created directly. It will be done by your runtime engine. It generates that objects here. Now here we won't deploy this table and directly put into the target of production or wherever it is required. Not only within the within the on-premise, but on cloud also we don't transport and do this table from here to here. But only thing is we'll take this file, right, and copy this file into the AWS. There also it will be integrated with your. This will be executed by runtime, and the table is created there. Like this, every object with the help of files only will deploy it there, and runtime will be executed. It is created. And one more concept here it is cloud foundry, and one more is microservices. Even now Java also, as well DevOps also, they're using the same concept, microservices. It is for your database runs as a separate service, then application service as a separate service, and your front end also will be running as a service. Everything will be running as a service in your cloud foundry. And everything will be separate. Even one service is failing, your whole server will not, services website will not be down. But you can create one more instance of the service. That is what we can call as microservices. We split everything is split into services, and we can create multiple instances of the service. Okay, that will come later. Cool. So, but you can just see that there are some advanced topics which are there in this XSA. XSA uses cloud foundry and microservices techniques, and this XSA supports multiple languages, not only JavaScript, but Python. This is some languages. Got it? So what I come to know is from the architecture, we have a default web server. No need to go for a separate server like Tomcat, IIS server, right? WebLogic. Now there are a lot of servers which are there in servers. No need to have it. It's already inbuilt within your server for your web development. Okay. So which is all which happens here. So when you come to this, HANA is on top of this, but when you see what is, you'll be sometimes confused. Uh, what is this Fury, right? So Fury and all. Okay. So when I take HANA, this is my HANA database. On top of this, you install S4HANA. We have S4HANA, right? Now, what happens is in S4HANA, basically for your web application development, now the new and advanced HTML is your HTML5. It has got a lot object-based creations and other things, right? So HTML5. Now what SAP has done is, to this HTML5, they have made some more extensions. Means they have created some more objects like buttons. Then after that, say drop-down buttons, a lot of dynamic, a lot of hundreds of components they have created using HTML5. So extension objects to HTML5, HTML plus extension objects, we call it as an UI5, user interface file, UI5. I'll take it little bit X. So UI5 nothing but HTML5 plus extension of HTML objects is known as UI5. Now using this UI5, SAP has already built some application, sales order application, purchase order application. So like this, there are hundreds and thousands of applications. Using this HTML, they created some applications. And these all SAP applications, SAP UI5 applications, which are built by SAP, and the bundle is known as POP. This bundle is known as POP, which will be used for your ECC applications. These applications will be used for your SAP S4HANA applications. Got it? So a Fury is not a separate language, like it is a framework, or you can say it's a bundle of your UI5 applications. So when you go to your website, a little slow. SAP UI5 libraries, you can search for this. So we have UI5 HANA on demand, or you can say documentation. Okay, we'll pack at 1 o'clock for the lunch break, right? So from the afternoon, we'll do the practicals, because we covered the theoretical aspect. But only thing is, little bit is there. Like I'll show you actually what is column table, how it is stored, and how to modify this. Then compression is one important thing, and partitioning is another one important thing. So these are all the base of your HANA database. So these are all practicals. We'll do it in the afternoon, right? So see here, this is SAP UI5. Okay. So within this, we can see licenses. For example, button, add button. So you'll have a code for this, how to do it, navigation, routing, hashes, steps for this, API references, and your controls for this. say combo boxes, custom items, dialog, right? For example, you take a combo box. So use this sap.m.combo box, right? sap.mobile.combo box. And you have your properties, aggregation, what events will be used. The whole documentation is being made. So this is not an HTML file. So this is an extension of your HTML file. Okay. So if you want to change this, what parameters, what controls, how, what code has to be given, everything is given here. Okay. What methods are placed in this. So combo box.select, .attach, .read data, like this, whatever things is there, it will try to get this within this. Okay. Close method. Okay. Combo box.close. Then destroy items. Then tag change, exit. So this is all your functions. Now it is nothing but your HTML file plus SAP has created all this particular list button, this, that, and also you have got samples also here. So you want inputs, list, pop-ups. So if you want to create your applications, these are all the objects which are there. Using these all objects, SAP has already created your business content like applications already created, and that applications are known as pure applications. The front end is known as pure applications. Now you can do with that or transactions with that, or you can go to GUI also and do it. Both options are there, whichever is flexible. So users are trying to do this. Okay. Cool then, fine. So we'll pack for the lunch, and what time will be back?
Half an hour break should be fine, I think. Half an hour to 40 minutes max.
45 will take, yeah, no worries. It'll be fine. Should be fine. No worries. Right? So you'll be back by 1:45. So already it's 1:05. So you'll be back by 1:45.
Yes, 1:42.
Right?
That should be fine. Thank you.
Okay. Chalo then. See you guys at 1:45. We'll assemble back.
Yeah, thank you.
Okay. Thank you. You can see here that we have overview, the system overview, like you find out like when this was first started up, then whether it's a distributed system or not, scale up or scale out. So you can find out here whether it's a distributed system or it's a scale up system, right? What is the version? Like 2.0 is a version and 04 is your service pack here. SP04, right? Now build time is this, and platform is your SUSE Linux Enterprise Server 15 SP1. So this is a SUSE Linux. Now SAP tells that only two operating systems are supported. One is your SUSE Linux. So here when you see the OS for your HANA database, there are two databases, two OS. One is your Red Hat and another is SUSE Linux. Is it fine? HANA database cannot be installed on Windows operating system. It is only for Linux system. Is Red Hat Linux and SUSE Linux. Okay. Next. We have statistics server, then we have pre-process server. So pre-processing server is for text analysis. I told you like one more text engine what we have got it. So that is mainly for processing the text. And we have an inbuilt web server, which is known as your Access engine, and the latest one is your Access A, the advanced one. So Access server means extended application services, right? Now we have host agent for, this is not a service, but these are the tools what we use it. For remote start and stop, we use SAP host agent. And for updating your software to new patches, we have your software update manager. So we call it a SUM, SUM. And one more is the lifecycle manager, LCM. Nowadays we use more of your LCM as a lifecycle manager for your installation, upgradations, everything of your software. You can just do with the LCM tab, right? Okay. Now this is the same one. So what we have, this is your index server. On top of this, you can have your reporting tools. Like by default, we have VO tools as a BI tools, like the web intelligence, crystal reports, dashboard designer. Then after that, Excel, simple Excel also will connect it. Then after that, this is a analysis office for MS Office or MS Excel, what we have it. So these are all the tools by default for your reporting on your HANA database. You can use Tableau also, ClickSense, anything, because anything which can talk to your ODBC or JDBC can be connected to this. So connecting to HANA database is very easy. Just you have some ODBC driver or JDBC driver, you can connect to that. Next, any development, any administration, you want to do it inside the HANA server, then we require a tool called HANA Studio. And this is an Eclipse-based tool which is made in Java, right? Okay, mainly we have tabs like administration, modeling, then development, then BW project, and ABAP project. So these are all things which will be using it more often. And for replication from your SLT, right? SLT, we can use replication agent, then after that go for replication server. Your SDI connectivity also can be there. And we can use your BODS also to connect to the business object data services to connect to your HANA system and get that data from outside world, right? And we can use SAP systems. SAP systems, better is your SLT is what we try to use it. So reporting tools on top of HANA, then ETL tools in order to get the data, and the modeling tool or administration tool for this is your HANA Studio, the front-end interface for the users. Okay. Now, when I try to show in this, in double click, you can see the SAP HANA used memory. Now, totally we have 188.9, means approximately 190 GB of data is there in the server. So the total operating system plus your programs, everything in the OS plus HANA database is totally 1889, which has been occupied. Right. This is the size. We can see the database resident. There is no resident memory, and what is physical memory total available is this much. Okay. Fine. So here SAP HANA used memory. So to HANA we allocated total 125.50, out of which peak used memory it has gone to 22. Currently, how much it is using it, and peak time at particular point of time it has gone to 22.73. That is what max it has been used. Okay, and CPU usage you can see out of 100%. So currently it is running at 3% utilization, but peak it has gone to 40. So you can find out like peak means in a day or somewhere and all. So how it is going in. Sometimes it may go for 100%. Will come to red. They needed to find out like why it is going in, what times it is going in. For example, 12 o'clock or night, 10 o'clock it is happening, or 12 o'clock is happening. What times it is increasing, what jobs are executing, right? That and all you can track. And this shows your disk usage. Like as I told you, right? There are two types of disk. One is your log volume, this is one, and this is your data volume. For traces and all, error traces, other thing trace files will be stored under this path. So when you click on more information, you can find the details about the storage location of your log files and your these files. You can see all of the bad files it is trying to create and save it. Okay, so this is all about it. And when you go for your, say for example, configuration, now this is the heart of your administrators. The whole thing they try to do it from here itself. So when you go for, say for example, save point, save underscore, see here, save point underscore interval underscore s. So for persistence, for writing the data into your from log volume to the disk volume, so it takes, say for example, data volume, it is save point interval is 300. That means 5 minutes. Now if you want to increase the time, say to for example 10 minutes, you can make it as 600. Change the value and click on write. That should be done. Currently don't make any changes because 5 minutes is normally suggested, right? Okay, so this is what it happens. So first, a little faster, we'll just see what is an row store and column store, how the architecture will be there. As we've seen, row store and column store. So row store, for example, you have some medical files and say mechanical files, right? So different types of files are there and they're mixed up. Now there are 1 million records here. Now when you're trying to put a file here, what you will do, you'll keep a file over this. Keep appending. Same like this in your row store database also. The records are appended to the last. But when you search for the data, insertion is faster in row store. But when you want to search for the data, then what happens? So your mechanical file may be here, 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 here. So you don't know where it is. So you need to search the whole records in the row store for particular record service. Whereas in your column store, insertion, it will take some time because you're trying to put in a particular column. So for example, medical files, one rack, and this one will take one rack for this. So when I want to see the medical files, then I'll come to the bottom rack and open it. Okay, medical files, how many are there? I'll count it. So for aggregation of the data, or for reading purpose, always your column store will be faster. But insertion will be slower because while inserting it has to find out in which particular column I have to insert the data. Okay, fine. So in row store, unnecessarily you'll be reading each row sequentially and get the data. But normally in your column store, it's more faster there. Now, this is the main one for this. How the data is being stored in your row store and column store. So in HANA, for you, when you see a table, for example, sales table, whether it is a row store or column store, it will be appearing to you as a table only. But in the database, when it is storing it, it will store each record tuple by tuple, record by record, it will get stored. Okay. Now, when you see in a row store, India chocolate and 1000 will be one row. Then India ice cream in 2000 is another row. So like this, it writes sequentially. But in a column store, you can see here that India is one column, will be stored. Second column will be stored next. Third, it will be stored here. So now here, while inserting it, no, it has to find out for each column where it has to place it, sort it algorithmically. But as row store, it directly append the data. Now, when you want to calculate the total sales, then say for example here, if you want to find the total sales, 34775. But when you're trying to read here, what happens is India chocolate 1000. Yes, it has got one sales. Again, read each row here. Again, read each row. So now, honestly, I'm trying to read and what are the data it is. If there's millions of records, then it impacts. So first, I have to find out where it is. Then after that, take that particular fields and aggregate it. But whereas in a column store, if you want to aggregate the sales, so instead of searching all these columns not required, directly aggregate the data here. So total 76 will be getting. If I tell what is the min quantity, what minimum sales 500, what is the max sales 4000. But here, if you want to find out, again I have to go from starting, maybe the millionth record also. But here it's faster. If you want to find the count of India, it's faster. So indexing or aggregating the data is very fast in your column store. So for OLAP purpose, we use your column store, and for OLTP purpose, we can use your row store, memory, in-memory row store. Is it fine? No.
Ravindra, can we switch anytime row store to column store to row store? Like
Yeah,
even then
can
the data
do
is
it.
table.
Yeah, can do it, no problem.
Okay.
Right? So row store to column store to row store, anytime you can just modify it. That's no problem in that. Okay. But when you save that, again, there is very important concept called delta merge concept in column store. That will come next. Okay. So I'll show you practically how it does, how it happens, and one more architecture is very important there. That is your delta merge concept is a very important factor. That I'll come to that. Okay. Now, so the heart of your storage, you should understand that this is the main very important diagram for your, because some diagram they told that they'll show that this is one column, two column, three like this. It's not like that. It is not stored in column. It's here it will be in sequence only. But the only thing is it's not in one place what is shown. So you can think logically that this is one column, second column, third column like this. Okay. Now,
Ravindra, sorry to interrupt.
yeah.
Here, Ramesh. So here, row and column store data level. So what happened to HANA indexes when a table is moved between row store and column store?
That will be regeneration. Huh? So everything will be regenerated. So the previous ones will not be same as the index whatever we have there. So row store indexes are different, and this is column store index will be different, right? It has to regenerate totally because the architecture of storage itself is different. Huh?
Okay.
So then again it will be regenerated. That's not a problem.
Yeah. Okay.
So whenever you convert it, the data is that only, but only thing is it will be regenerating it.
Oh, okay.
Okay. Yeah. So now, when you go to SAP logon, new system, so we have one server called Bw4Hana 2. So this is a server which we'll be using for Bw4Hana. So just double click, you'll have this interface and go for SAP HANA and HANA@999. So when I log in into this, now we can see here that when I go to RSA1, in Bw4Hana, so we don't have this modeling tab at all. right? Modeling tab is not at all there. So we don't do any administration, no new development in GUI. Now GUI is only for some unsupported HANA objects only. They have just kept this. Otherwise, over a period of time, this also will be gone, right? So the whole modeling, the head, like head is being removed, and only body is there in the SAP wheel. What is the use of this? The heart of your thing is what? Your modeling tab only, right? So we don't do any modeling within the SAP wheel. Okay. Second, that is the main difference. First, when you see the GUI and appearance spice, there is no modeling within the SAP GUI. So modeling will be done in HANA Studio only. Second, when you go to the system, you can go to status. So within the status, you can find out here from the product version, what is the version of SAP we are using it here. So we are using DW core, means this is a BW for HANA server. And currently we're using 2.0 SPS 11, SPS 1. Is it fine? This is your BW content. This is a BW content for that. But the main core thing here is you need to find out DW4 is the BW for HANA version. It's a data warehouse component. And here BPC for HANA also is installed here, right? BPC for HANA. Okay, next. So the application server, what we are using here, so I'll show here in the diagram. The application server, what we are using here, the BW for HANA is BW for HANA 2.0 SP 01. Is it fine? This is what you need to check it. And we need to find out this application server will be talking to the database server. We can install this application server in Windows, no problem. NetWeaver server, so BW for HANA 2.0 can be installed on Microsoft Windows also. This OS can be Windows or Linux. Is it fine? It can be Windows or Linux. Either of the operating system is supported for your BW for HANA application server. But for this database, we require only Red Hat Linux or SUSE Linux. Fine. Now we'll find out what is the database version we are using it from your BW server itself. Now we come down, here you can see the release is 2.04, HANA 2.04, and the database system is your HDB. HDB means HANA database. So this will be same for everyone. So here it is HANA 2.0 SP04, right? Okay. Now, how to connect to your server? Now, BW for HANA is installed on HANA database, right? Now, which database is it? What is the name of the database? What is the ID of it? And what is the server into which it is connected to? So the host here is, this is the name of the host. The server IP address or server name, you can find it from here. And this is what HBQ/22. HBQ and ID is 22. So you can take this as host this Bw4Hana, the server or IP address, whatever it is. And here it is HBQ. System ID and instance is 22. Is it fine? So as I told you that HANA 2.0 is a multi-tenant by default. It is not single tenant, it is a multi-tenant. So multi-tenant, your multi-tenant ID is HBQ and the system ID is 22. Now, this is fine. And what is a schema in which all your BW tables will be stored? So that is your SAP HANA DB. So you can find out from here. This is a schema is SAP HANA DB. So just write all the details here. Local schema or BW schema is SAP HANA DB. Right. We'll connect to the bottom system itself. So these are the details of this. This application server has to talk to this server. This may be in remote server, right? And it will be logging into this particular server and ask particular database and go to the schema and search for the tables from here. Okay, now I'll just enter. Let's go to HANA Studio. So this HPQ connection, I'll just remove it and add it one more time. How to add this SAP HANA database in the HANA Studio? Just right click. So first thing is you should be there in SAP HANA Modeler. This is where we'll try to do our SAP HANA modeling as well as creation of tables, procedures, functions. Little bit of development we'll be doing in the SAP HANA Modeler. Web development will be done in SAP HANA development. That is your JavaScript, Java, Node.js, everything. We'll do it in the SAP HANA development. So mostly web development will be done in SAP HANA development. Okay, administration. Normally your basis administrators will have this admin tab. So they'll go to admin tab and start doing administration. But for us as a BW consultant, we have to go to this one, SAP HANA Modeler. If you're not able to find this, by this side of it, you'll have this open perspective. Click on this. Now in this, you can just search for your perspective here. This is your SAP HANA Modeler. Click on open. It is done. Within the system, go to add system. Now, what is your server name? The server name is this one. Bw4Hana 2. Just copy. First take from your server, copy it, do it step by step so that we understand better. Bw4Hana 2. What is the instance number? So here you might have seen the instance number is 22. Now, what is your tenant name, tenant ID? That is your HBQ. So take it as a multi-tenant and give it as HBQ. Now, you here as HANA. User, what will be logging in is HANA. Underscore, we can give Ravindra. Your name, we can give it as okay, HANA space Ravindra and click on next. Now, in order to log in into the HANA database, so we need to provide here the username and password. So here give it as HANA. So the username and password is everything is same for everyone. So you can just use the same thing and go to password is HANA@999 and finish. Now it is done. Is it fine? So this is the process how we'll try to do it. So when I go to properties, Okay, then just create a connection first. Now, when I go to the SAP HANA database, inside this, go to your catalog. Within the catalog, you will find the schema here called SAP HANA DB. This is the schema in which all your BW tables for your ADSOs, composite providers, everything will be created under this by default. Scroll down, go to your tables. Within the tables, now say for example, you want to search for the table which has, say for example, go to filter /BIC slash something table which is starting with A, means ADSO, right? Don't give any star, just click on this. Now you can see these are all your ADSO tables which are stored in your system. So when you double click on this, you can see that this is the structure of the table which is created in the BW, and what type of data table is it? It's a column store table. In which schema it is created? This is your SAP HANA DB. Now if you want to view the data, just right click, go to open content. You see that this is the data what we store in your ADSO. Fine. So what I want you people to do is just create one connection for your SAP HANA. So we can start working on this, right? So take some 5 minutes and complete this exercise. So once you're done, you can just give me in the chart, right? You can in your chart you can tell completed, or yes also is fine. Yes or completed you can give, so that I can understand that is you're done it. So that we can also track that you're doing your practicals perfectly. If anyone having any technical problem, please inform me.
Sir, password is HANA at 999 all caps. HANA.
I'll type it up.
Pardon me?
H is capital.
Okay. Thank you.
And remaining is small and 999.
Okay, thank you, sir.
Avina, there should be a notepad file
Yeah, there is an access file there.
on desktop.
Okay, shall we proceed further?
Ravindra, one thing.
Yeah.
How was that we were able to differentiate multi-tenant or something? I missed that. Can we be able to differentiate from SAP GUI?
multi-tenant के लिए
Double click on the server setup. What you configured there, it was mentioned. Dinesh.
In Studio or GUI?
GIS Studio. See the screen share
Okay.
right now.
Hmm.
So when he double click there,
Yes or no here, right? Distributed
this is
system.
an scale up or scale out.
Okay, right, yeah.
So this is not single tenant or multi-tenant, right? So
Means when,
this,
yeah, mainly the question was when we were adding system, like
yeah.
what container we should be selecting, looking at the GUI
No,
view.
because see, by default, 2.0 is a multi-tenant, right? There is no single
Okay.
tenant at all.
Mm-hmm.
So by default, there will be a system DB and tenant DB.
Mm-hmm.
So if you want additional, you can add with this using LCM.
And slash instance is always it is the kind of naming convention, right? If you go back to his
Yes.
GUI,
Yes. So always it
slash
will be your
22.
system ID / instance.
Okay. Yeah, fine. Thank you.
Yeah. And one more important thing for your HANA to remember is, now what is the instance number here? 22, right?
Mm-hmm.
So whenever any tool wants to communicate to your particular through ODBC or the database, right?
Mm-hmm.
So then your port will be prefix will be 3, right? Prefix will be 3. Then our suffix will be your instance number 22. Sorry, middle one is will be this, and suffix will be 15.
Okay.
So 3 is a prefix. Okay. Plus mean to say comma, I'll keep it. Your instance number, comma, 15 is a suffix.
Okay.
So some instances will be 00. Mostly the instances will be 00. So you'll find the ID as 30015. Is it fine?
Yeah. Good.
Okay. Now, as we are discussing about this column store and row store, so it will be as like your, say for example, this is your more showroom or something like, and you have all of items which are there, the grocery items here. Now, say for example, when I want to find the number of this particular baker's packet here, right? How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now I'm able to count this, right? There are 11 packets here. Now, for example, so 11, and in the bottom also, if you take it 11 and 11, 22. Now I'm able to count this, right? When I'm going for column store, I can count the number of baker packets here. 22 packets are there. Cool. But if I try to, they are arranged in the column wise, and we know that each data is there in the same column here. So in the same column, so we are able to count it faster. But if you jumble these items totally, then this may be here, this may be here, this may be in the last also. So we need to search from first of the row to the last of your row. So row store means it will be jumbled, it will be appended at any place, we don't know. But column store always arranges in a particular column. So that we can come directly to the column and find the count of this column, sum of this column, min of the column, max of the column. So like this we can find it. It's just like your dictionary also, right? In a dictionary, what happens? If you want to find the word called sorry, so I can directly come to yes, oh, just within a second I can find that particular word. But the same thing, the dictionary is not sorted properly and it is totally jumbled. Then first of the page, you have to read it from the first, it may be in the last page also. So it makes like this. Searching will be slower in your row store, whereas in column store, it search very fast. Right? Okay. That is one advantage for us. But now what SAP is trying to do is they don't want to keep one separate table for OLTP and they don't want to keep separate table for OLAP purpose. But they want to have this data written, writing also should be faster, as well as reading also should be faster. So when you see S4 HANA, all tables, ERP tables, they're not OLTP tables. Because we know that when it's a transaction system, it should insert the data faster, then it should be in memory row store. But you find that 100% of the tables, mostly, which are transactional tables, or 90% of the tables are column store only. Even BW also, your for example, info cubes or DSOs, what is there in BW on HANA or BW for HANA, every table what we create is your column store only, not row store. Is it fine? It is 80 to 90% column store only. Then what SAP has done, why they're using column store? For writing purpose also, like ERP system also they're using column store, and for data warehousing also they're using column store. So for that, what happens is they have come up with a new concept called delta merge capability. They show us. So this concept is known as delta merge, right? Okay. Otherwise, what I will do is first I'll show you one practical. Okay. So then I'll go for the delta merge practical delta merge table, how this is created. Okay. Let me finish this theory, then I'll show you practical. Cool. Delta merge. So when you see the delta merge, column type architecture, in one column store, internally you'll have two more tables called main table and delta table. As we know that this column store table has got one drawback, that writing into the database takes some time. And we want to use this table for transaction purpose also for ECC systems or transactional systems. So what SAP has done is inside this column table, they kept one row table so that any writing you want to do it, first write this to this table immediately. So that writing, my problem for writing is being resolved. So any data, what are you going to write? Like a transaction system, all the data will be written to your delta table. Now, one more benefit of this is writing is going faster as well. All the data, what we have, historical data for last 5 years, whatever we have it, it is compressed, is read optimized, it is algorithmically calculated to get the best performance. It's all sorted column tables which are going to be there. So all 5 years of data is like this, kept in a columnar fashion. Now, whenever you're writing the data to this, what will happen for one record, for example, when you try to update, and it may disturb this whole 5 years of data, which is this, and it takes some minutes or half an hour also to adjust that particular single record into this particular table. So for every table, if I try to keep on inserting it, then what will happen is your performance, then reporting, every time your report will show hourglass only, telling please wait, something is going on. Because while reading, some people are trying to end users are trying to insert the data also. Then what is happening? It doesn't solve your purpose. So whatever the data you write into your delta table, it will be there within this up to 1 hour or up to 1 GB of data, or still conditions are there within cell count also, a lot of things are there. So best thing for us is 1 hour or 1 GB. This holds good for us. So after 1 hour, whatever the data it has collected, it will update as a one job into the main table. Instead of every commit, we try to write the data only after 1 hour. So then the data will be re-optimized again, rearranged, then so resorted, and we'll get the data back. So now, anytime you give a select statement to your particular column table, the read operations will become a union of both the tables, main table as well as delta table. Is it fine? So this concept of writing the row store data into the column store data internally is known as delta merge concept. Is it fine? And this automatically happening every 1 hour is known as merge doc function. This automatically updating your tables is known as merge doc. Right? Or we can say auto merging. So auto merge functionality is every 1 hour or 1 GB of data, or conditions can be there. Any questions? Okay, fine. Next. So one more problem here, what we try to see is, whenever you're writing the data, what happens, the data in the delta table will be put into the main table. Now 5 years of data is there. Now here 1 GB of data means, say for example, some 1 million records you got it. 1 million records it has updated into this. Now this 1 million records updating into the main table, when it is updating it, say for example, half of the records are updated, but half the records are not updated. But during that time, due to insufficient memory, this operation has failed. Then what happens is, now some data is mixed up into this. We don't know what data is mixed up, which records are mixed up. Now half the data is there here, right? It is copied, but it is not deleted, right? Half data is done. If next time you do it, for example, again 1 million records will be added to this. So there are chances that when there is a short dump happening up, so then it becomes invalid data. That is one problem. Second is, during the delta operation, right? Now the data is this, it will lock this particular table. During the delta merge, it will lock this delta table, so that no write operations will happen anymore from up to that point. So during merge operation, if any records you're trying to write into this will be lost, because it is locked, you cannot insert any new records. So these are the major two problems what you find within your delta merge during the delta merge operation. Fine. So for this problem, to resolve it, SAP has taken this one. So during delta merge, SAP will create two more tables, that is main 2 and delta 2. Will create main 2 and delta 2. Now whatever the 5 years of data, whatever we had it, main 1 data will be copied into this. And whatever the data is there in delta 1 also will be copied into this. Right? So it is keep on copying this 5 years of data into this, and 1 million records is copying into this. By chance this job fails, then what will happen is it will cancel this main two totally. So that I'm not going to delete this data, right? As it is, whatever is there, it will be there only. And it will delete this whole table and this whole table. And during that time, merging time, if any new records are updated already into this particular delta 2 table, it will update into the table later, so that we don't lose these records. Got it? By chance, if it is successful, so here there are some 50 million records, and here this is 1 million records. So when it is merged, this is 1 million records. So 50 million records plus 51 million records will be there in the main table. And the time of merging it, now as this is in lock, new data will be returned to your delta 2.
Sir,
Once your merge is over, then what will happen is this main one and delta 2, delta 1 table are deleted, and you will have only two tables, that is your main 2 and delta 2. So here how many records are there? We have 51 million records. And during the transfer, say for example, 100 records are updated now currently. Now this 100 records are updated into the delta 2 as it is there, right? This is how it happens. So every 1 hour in your column table, there will be 2 more tables created. And after that successful merge operation is over, it is being deleted again. So like this, for every 1 hour, keep on creating tables, delete tables, create tables, delete tables. Like this it happens. Is it clear?
hello, sir.
Yeah.
Can I say this similar to logistics initialization and deleting setup tables and creating?
No, it is entirely different. So that is a different purpose, right? So here initialization is your setup table, but that two tables are separate tables, right? Purpose is to collect the history, transfer it. But here, this is your setup table, and if you take initialization as a new records, but we try to put this into, at the same time you are putting into this table here. Getting it? See the process there in your LO, logistic cockpit, if you tell that, that is sequential, one after the other. But this should happen at the same time. Is it fine?
Okay, sir. Thank you.
That will be sequential. After setup table only you can do delta. Getting
Yes,
it?
sir.
But here your delta itself is a new data only, whatever you have it. And this old data and the new data both will be combinedly put into your main 2 table.
Thank you.
So purpose is different, right?
Okay, sir. Thank you, sir.
Yeah. Now, one big disadvantage with this process is, for example, your main table, main 1 table is having currently 1 TB of data. Or say for example, 100 GB of data is already there in this. Is it fine? Or 1 TB level, it is a little bigger, 1 TB. Previously 1 TB is there in main 1. At the time of merging, what is happening? This 1 TB data is already there here, and this 1 TB has to be copied into this main 2. Means, which is when it is nearing to this copying, that means here also it is 1 TB. Now here 1 TB is there, here also 1 TB is there. Means you should have double the space of your column table in order to have this delta merge operation. So not only this one, plus the new records, whatever it has come also. If it is 1 TB and here it is 1 GB, so 1 TB plus 1 TB, 1 GB data, double the into 2 is equal to delta merge space, what is required. If that space is not there, then this delta merge operation fails, telling that I don't have sufficient memory to copy my data into this temporary table. So most of the delta merge operation fails because due to insufficient out of memory OOM. OOM is a big problem in HANA. Is it fine? So this operation we call it as a delta merge operation, and normally when you're using maximum 80% of your column tables in your ECC or BW, that means your enterprise data is, for example, 10 TB. Then during merging operation you require another 10 TB. That means you require double the space of your enterprise data. Is it understood? How much you have your disk space. That is, you have to see how much space it is occupies in the RAM. Now double that space you should have for your delta much option. Into 2 you have to do it directly. Plus, say for example 10% add for those tables for this delta table and other things. Okay, fine. Next. So these merge types are two types. One is your auto, another is manual. So in the automatic system process, we have one is your auto merge, another is known as critical merge. Auto merge and critical merge comes under the category of merge dog. And when manually you need to, when you're trying to do it with the help of hints in the database and all, with the help of SQL statements, then these are known as your hard merge, force merge, smart merge, and memory merge. So here, auto merge will happen every 1 hour. But if you switch off the auto merge, then what will happen is your delta table will keep on piling up, piling up, piling up. But there is a threshold value given for that particular delta table also, even after 10 hours. If it is crossing this much of time, then in my critical condition, I cannot keep more than this, then your critical merge will fire it. Right? So critical merge in the critical context, this will fire in the merge top. Okay. Smart merge, normally what happens is you can view your SQL statements and there'll be some database hints. So when that particular database hint is being triggered, then it tells, okay, now I can merge the data. So like this, and based on the condition, I can merge with my SQL statements. Now mainly, when you go to your merge job, so we have an auto merge decision function in which you have said DMS is what? So DMS is delta memory size in MB. That is 1000 MB is equal to 1 GB. So when our DMS size is greater than 1 GB, or your TMD is your table memory merge delay is one, let's say for example 3600 seconds, means 1 hour. Is your gap between that to this is 1 hour, or DCC is a delta cell count in millions. This many millions of cell counts are there, or like this you can have number of things there. But majorly these two makes a major impact. So whichever is earlier, whether 1 hour or if within half an hour itself is 1 GB is filled up, then it will trigger. It will not wait for 1 hour. Right? So like this happens in your system. And this will be for all the tables, not for single table. 1 hour and this is for auto merge, where whichever table is there, at that time it keeps triggering this. Okay? Now, so I'll come to the practical, how to do this. So I'll take one Excel file. Inventory aging. So I'll give for this file for your practice also. So for the time being, let's take this. So I'm taking very simple data. Say for example, if you want to create one table for orders table, sales orders. Now let us create one small table here. Again, before going to the table, your schema explanation. Okay. I'll just a little bit brief because as it is, you know most of the concepts. So normally when you're doing your remote desktop, and if you're not using for at least 10 minutes or somewhere, then mostly that gets stuck up. Okay, it will be in fast state. So just keep it like this and it will reconnect it. So you can come back like this. Close it, just wait for a minute. So it'll be okay. So the concept in HANA is when you connect it to your HANA database, just come down. So every HANA database will have 4 folders or 4 areas. So first one is known as catalog. The second area is your content. The third one is your data provisioning, pulling the data. And the fourth one is for security, in which we create users and roles. We create users and roles within the system. Is it fine? Database roles and database users. Good. Fine. Now here, what we do is, for example, if you want to create a new user, I'll show you how to create a new user also from the scratch, so that we create our own data for the time being. Don't utilize more of it, but at least for your ideal how to create this user role, I'll just show you. So when you go, okay, I'll just brief out again. So user and roles, then after that, so in the top one, we have your catalog. Inside a catalog, you will have a schema. Inside a catalog, you'll have multiple schemas. And inside the schemas, you'll have your tables. For example, when I go for system schema, so you have your column views, EPM models, functions, procedures, sequences like normal databases, right? Oracle, SQL Server, you have your procedures, sequences, synonyms, tables, triggers, views, everything is there in your normal databases also. Same like this, your HANA supports all this data, all these functions which you have. Okay. Now, synonym is a space where the development takes place, the storage takes place. Now, if I take like this, now this is a whole RAM of your system. Okay, and you are user one, for example, your user one, and there is another user called user two. Like this, we have multiple users. Now, when a user is being created in the system, database user is created. By default, a space is reserved for him for his storage as well as development. And this storage space, we call it as a schema. And all the schemas normally we can see under a folder called catalog. Under catalog, you can see multiple schemas. Now this user one, when he's created as a user, for him, a schema is created and the name of the schema also is user one. This is like your favorite schema or a user schema or a local schema. And whenever a user is created, for this, there is one more schema created for him, and the name of the schema will be user 2. What is the schema name? User 2. So username and this user schema will be same. Right? Now, like this, I can create for user 3 one more schema here. So always there will be some space. In this schema, this user can create tables, procedures, views, functions, synonyms, and triggers. Right? Like this, we can create multiple objects here. Now, if this user is pertaining to this user schema, you can create anything here. Now, if This user wants to create this component, so the same thing will be there for user, all these users. It is user 3 schema. He can create his own tables. Now here, if he wants to create an EMP table, yeah, I can create it. Now this guy wants to create in this schema EMP table, no problem. And here EMP table, yes. But when you want to select from this EMP table from this, then you can give it. If you're logged in into this one, automatically it will select star from this EMP table, you'll be able to see. But if you want to, you're outside the schema from some other schema, you want to access this, then you have to give it as user1.emp. That means schema.emp table. This is user2 schema.emp table. Like this, you can access it. Okay, but in the projects for your developments, we will not be using any user schema, because by chance you join and you're doing, all people are doing development on this, what will happen? You left the company, then your project is closed. So we will not create any development in your local schema. This is only for your self purpose, but normally we create one schema for our development as a separate schema. Say for example, this one I created. Say for example, CenturyLink project. Now the administrator should give the rights to all these people. To this schema, I should have this access to the schema, and user 2 also should be able to access the schema. And this guy also should be able to access. Whoever is given the access, they can start creating the tables. For example, EMP table here. Then say for example, orders table, material table, everything. He creates orders, he creates material, he creates like this. But I cannot create another EMP here, because in one schema you can have only one table name only. Is it understood? Fine. Now, second is physical tables. Now this is CenturyLink project, and I will make this project name fine. And here I created one orders table here. So this is my orders tables. Table will give it as brown color, say for example. Now, when I want to do some reporting, so all the reportings will be done in another folder called catalog. Reportings will be done in this called catalog. And in this area, we have seen, right, this is a big folder. It's only grouping, nothing more. And catalog is nothing but, it's not a technical object, but it's a grouping. Inside the technique, this is the catalog. What will happen is, now this will be used for your reporting people. Say for example, in your ECC, what is the topmost one? What will have? Logistics is a folder area. Under logistics, we'll have material management, MM, SD, finance. Under MM, we can have, say, purchasing. And another is, say for example, inventory. Now, under this particular purchasing, now I'll create a purchasing cube. I want to create one purchasing cube. Under inventory, I want to create an inventory cube. So that if any user wants to search in the report, like folder wise, logistics, MM, purchasing, like BW, what we call this as info area. And here we call this as a package. What we call this? Package. This is your sub package. This is your sub package. And this is your model. And this is your model. So nothing but calculation views. In HANA, we call this as calculation views. Now calculation views will not store the data like your info cube. They're not physical, they're virtual. What happens is they'll try to consume the data from your tables. For example, there is a material table is one more thing. There is a material table here. Now we want to combine your master data and this. Then I'll try to link this with this to this. So master data also as well as transaction data. We'll just use physically the data is stored in tables in your schema. Correct? Physically the data is stored in, for example, 1, 2, 3, material M1, M2 materials, and this is 4, 4, 5, 7. So this is the data for transaction data, master data. You can check. And the outside world, like your Tableau or View or Excel reporting tools, will or can talk to your models only, not directly to the tables. You cannot directly talk to the tables. You cannot directly talk to the tables, but through models only we'll try to access it. So for the reporting purpose, we have catalog, and for the storage or creation of your tables and other things and all, procedures, functions and all, scripts, everything, we do it at the level of your catalog. Is the funda clear?
Ravinder, that should be content, I think, right? Catalog and content.
Content, your content. Is it fine? No. One more funda here is this is known as your package. This is known as your package. The blue color things are known as your packages. Now packages can be transported from development to QA. These are also used for transportation. To prod. Right? So all these packages will be grouped under a component called delivery unit. So in PW or SAP, what we will do, all your transport requests or will be grouped, or all your objects will be grouped under your package, right? So for example, you created a package called JetBW is one class, we are trying to create a package. So first you have to transport that, and after that your objects, normally when you save it, it will be saved under your, it's not a local objects, but it will be saved under your class. That is your development class to try to do that. So here we call this as an delivery unit. So one delivery unit can have multiple packages. You can assign multiple packages. Logistics is one package. Now, say there is another project that also is there. You want to use that one also into the same delivery unit. So then you can, for example, logistics is one delivery unit. Then SD, sales and distribution, I want to keep it separately. Or HR is separate. I'll give another development package here. I'll create another development package for HR. And all these packages I'll keep under HR development unit. Right? So there were 6, 7 packages that I can put into this. When I transport it, then I just do the development of HR development unit. I'll just do it. All the packages also will be transported along with that. two purposes. One is for transportation also, and other is whenever you do reporting according to your particular packages, like an info area and sub info area, you can just put. Okay, now first I'll come to this part. So you people don't create a user, but just I'll create one user, right? Because the more the users will become too shabby. So for the demonstration purpose, I'll show you how to create a user and how to make a connection in your HANA system. Okay. So let me go to security, users. I'll create a new user. Inside the username, I will give it as, what is the username shall we give? Century link, or I'll give it as link 0. Okay, I'll give it as link 0 is a username. And the password I'm giving here as, say, for example, India123, so that it is easy for me. Normally, the administrator will give you, for example, administrator creates and gives to you, and he gives you, otherwise I'll give initial and later I'll change it to India123. INITIAL initial. Now I'm telling you have to change. Otherwise, if you tell no, then whatever password you've given it, same thing takes up. And from ECC, when you're trying to pull the data, right, and you're using client for your development client, your client 800 is using it, you can give the default client here as 800. Okay, and what is validity of the user? For example, is in contract for 1 year, so you'll put validity from this to this. Only it is valid. Now, in the roles, normally for HANA modeling, we require modeling role. So modeling is sufficient for us. But still, if you want to have more of it, then AFL role, I told you, application function libraries and all will be there. So your other roles will be there. So I'll take all roles, control A, take all the roles. There are some system privileges, like for backup, you should have a user. For creating a schema also, you should have a user, right? So create schema. Without this, you don't have the right to create a schema. So I'll take up all the rights. Cool. Now click on activate. Just run this. Okay, this user doesn't have some rights for doing all these things, and some rights wherever red is there. So rights are not given for this totally. Okay, not a problem. So now the user is being created for this, known as links. So when I just come down, click on L, you find link 0 is being created as a user. Now what happens is, when a user is being created, now I want to log on with this user. Let me go to file, or with the side of this here, add system, you can find a click button here. Go to add system. Now your server name, BW HANA 2, instance number 22. Then what is your tenant database, HBQ, and the user is a description only. It is link 0 user or whatever you can just put it. Next, authentication is your link 0, and password is initial. And when I click on finish, it will ask me what is your old password, and keep your own password here. So I'll give it as initial click on finish. Password is changed. Now you're logged into the system. Now once you log into the system, you can go to the catalog. So within the catalog, as I told you, for this user, database user link 0, there is a local schema which is created here. What is your link 0? This is your favorite schema, but don't do any development under this link 0. Right? So you are the owner of this and you have all the rights. Cool. Now, whenever you want to create a project and everyone should work on this project, then what you can do is we'll just give it as, say, for example, now if you want to go for SQL console, right, just right click from here, you have an open SQL console. Otherwise, with the side of this, you have an open SQL console. Now you can create a command here as create schema. Create schema, for example, century link underscore project. For example, owned by link 0. So I'm the owner of this. Okay, and normally you can end your SQL statement with a semicolon. So insufficient privilege. So this we don't have the create schema privilege. System privileges are not given here. So then what I will do is I'll go for HANA user itself. So HANA user inside this and create it. So I have the create schema, but I cannot grant to others. Getting it? So if I am given the grant to others permission, see normally when user exit, I'll show that. Okay, fine. Then now this guy, all the users, normally whoever we're giving this permission to this. Okay, so when I try to refresh, we'll have your essential link project here. See, essential link is a schema created, and under this again we have your tables and other things which will be created. Cool, yes. So this is how we try to create users, and once a user is created, start using it. Okay. Otherwise, you can also start creating one user. So I given as a link 0. So with your ID, create one user. Okay. So create a user and start with the development now. What I will do is take some more rights for that. Okay, fine then. Start with the practical. So I want you people to create one user, log in with your user ID there, which is given. And you can first give this as initial and later you can change it to India 123. And after that, from your HANA user, create one schema as century link underscore project I created. So you can give it as century link underscore project 1, 2, 3, 4, 5 like this. So I can see multiple projects there. And I'll give this, okay, I'll do one thing. So within this particular HANA, so you can see here the user is HANA here. And if you right click on the link, open the OpenSQL console, you can see here the user who is being logged in is your database user is link 0. Okay, so by this you can find out which user the console has been opened with. Currently you are there in this particular schema. Now I'll give the code for you to create one orders table. Then copying, and first I'll give the create. So inside this particular schema, if you want to create a table, just right click and create a table. Now here we give it as create column table. So normal database table doesn't have this property. Create column table orders, right? Create column table orders, and this is the details of the orders here. Varchar date and varchar user things. Now in order to create the table, if you don't create anything here, you don't supply anything to the create statement, and click on execute, the table is created. Now within this link 0, go to the catalog and right click the tables and refresh. This is on the link 0. Sorry, essentially link is on that. So link 0 I created in a local one. So within the tables, I find here as an orders table. So by default, if you don't specify also, it is created as a column table. In previous version 1.0, it used to create by default as row table. Now, so this is your column table which has been created. Fine. Now, if you want to create a row table specifically, then give this as create row table orders 2. Click on execute. Right click. Now refresh. Now there are two tables here. One is your column table, and the icon here you can see that is a row type. I mean to say it's a row table. Now double click on this. You can find here that is a row store table. All right. Now, what is the difference between here the architecture wise when you see here for orders? In column table, when I come to runtime information, you'll have two more tables inside this one column table. You'll have two more tables. One is your delta storage, another is your main storage. One is delta and main storage. Whereas your row table, when you go to the runtime information, you won't have any row table because it's always appends. There is no requirement of your any tuning which is to be done in this. So it's direct appending to this. So only in the column table you'll find this row table and column table. Now to the funder, when I'm inserting this particular rows into this, for example, inserting some data into this particular table. So let me go to essentially link is that is in HANA. So I close this. Now to the SQL, Control A, Control V. Insert into orders. Click on execute the statement. So insert into orders values. These are the values what I'm trying to give it. Inserted. Now if you want to see the data, you can give it as select star from orders and give a semicolon. Select only this because if you just execute like that, then everything will be executed from the starting. So only this 15 line should be executed, selected, and click on execute. You see the data. Just like your normal SQL, you can just keep on querying the data from your database. Okay. So once you insert the data into your database, that means we inserted this data means it has to go into delta table. Now when you see the orders, previously there was no data at all. Now the first time when you try to insert, you can see that there is 143 KB of data written to your delta storage. So the writing is happening into the delta storage. Now once this is done, what has to be happen? So this will be there in the delta table up to 1 hour or 1 GB of data. So when that reaches that threshold, after 1 hour, it will auto merge. There is a job will be triggered auto merge. And system will write all the delta table into your main table. But in emergency, anytime you want to do that, or if anything fails, job fails for auto merge, and you want to do it a manual merge, then right click this table and go for perform delta merge. This is your manual merge operation. When you click on this, it tells that the action committed the entire tables from delta storage into the main storage. Do you want to do it? Yes. Now, once done, see, total memory consumption is 157. Okay, and 12 records are there, and storage in the disk is how much? 76. Now, when I click on refresh, now you can see that it has gone to delta is 55 KB and the main memory is 52. Actually, this is not the data. 55 KB is not the data. It is a table space which is a little bit reserved for just storing it. That's it. Correct? So total, we got, say for example, 124 GB total memory consumption and still 12 records. Now we merge the data into this. Now let us insert one more record now. One more 12 records. 52 is there, 55. When I click on again refresh, the data whatever you written after that merge operation will keep on writing the data into this one. So again it has gone to 140. But when I merge 12 records plus 12 records means it should be double the RAM, right? 52, 52, 104. But when I refresh it, the data not merged in. Okay, after storing this, I'll go for again merge operation and refresh now. See, still it is 55 and 52 only. So if I try to execute this 10 times also, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, multiple times I executed. Now it will be on refresh. It's come to 193. Right? 143 was before, now it is 193. Now when I go for merge now, and I go to merge and refresh, now again it is going to 55 and 52 only. So this is due to compression. Due to the compression of the data, when the same records are there, it will not increase the memory, but it will be compressed. Okay, so I've shown you how to where this particular delta store in main store is there, how to insert it, and how it goes to your delta table. Then after that, how to merge it. Auto merge, I shown you auto merge function will be there in your configuration, right? In a merge dog function. And if you want to do it manual merge, you can just do this one. Next. By chance now, what is this table here? Orders to is a row table. Now, if I want to insert the data into this, I'll go for Control F. Replace your orders with orders to. Orders table with orders to table. Replace all this. Now, insert into orders to. I want to insert into row table now. And click on execute. Now for me, whether it's a row table or column table, my select statement will be same only. Only the storage and internally in the database and the memory, that makes a difference. And it makes a difference to me when there are some millions of records, right? Small records, it doesn't make any impact. Okay. So normally when you use some millions of records, now column table may throw you the data within a second, but that will take say 5 minutes. Okay. So like that there will be difference. Now, the select statement for a row statement, row or column table should be same. But now one more thing is, for example, already I have a row table with the data. Now I want to convert this into column table. Then what you can do is you can give it as alter table orders to. Now it is row store, you put as column. Right? Now execute this. Executed. Now it is a row store icon, what you have it. Now right click, refresh. Now see that it has been converted into column store. Now previously, when you see the orders table, close data, okay, click it, it was a row store and there was no tables, multiple tables was not there, right? So now when you click on refresh, you can see that now this orders to table, which was a row store, is converted into a column store, and from there it maintains this delta table for this, and all the data which was there previously in the row store will be first inserted into your delta store here, okay, and it will wait up to 1 hour. When that is done, then the data from here get merges, and once it is merged, the data will be available in the column store. There is no data here, but it is fully constant. And now, once you have the data like this, and you want to convert this again into row store, by chance. Now, alter table orders to into row table. Insert and just execute it. So once done, now here before it was column store, refresh it, refresh second time. This is orders, huh? Orders two, now refresh, before it was column. Now again it is converted into row store. How many records are there? 12 only. Okay, so how much KB is allocated? 16 KB, which is good. Cool guys? Chalo then. So I'll just put the code immediately. So, or I'll just share the file to you, the whole file. We can do the exercise with this. I'll stop sharing and I'll transfer the file, right? Or disconnect. The file may be open. So I set the file. So create a table, insert the data into your row table first. Then after the create row table as well as column table, put the data into this. I want you to modify the table also, row to column to do it, and give a delta merge operation also there. Here I'm trying to insert one more set of records now, and when you go to the orders table and click on refresh, it's going into this orders 2 is that one, so control F. Now just insert the data into your orders table, and go to orders table, refresh. So now it has come to 143. Now the data is there in delta merge. And if you want to execute this statement with the help of SQL, manual merge not by right clicking, but in your procedures somewhere, whenever you want to check the table and it's going more than this number of records, then you want to do it merging with manual merge with the help of SQL. Give this as merge delta of orders, whichever table you want to merge it, you do it. Then automatically, when you see this, it is done. You can do with this or with the SQL also. You can just do it. Right. So we'll try out. So once you're completed, please view your chat as completed.
Ravindra, where did you share that file?
Okay, it has gone to one person only, I think. I'll do one thing. I'll just send to all. Yes. Did you get it?
Yes, yes. No.
You're fine. So we'll have a small break also. Should be fine.
Yes.
3:50. The time is 3:50. So by 4 o'clock we'll again catch up, right? 4. Okay, can complete the task.
Sorry, Ravindra, you said something?
Yeah, can complete the task, which is creation of your tables and alteration, then merging of the data manually as well as with SQL base. You can just do it. Prashant, done. Just follow the this one norms, like if you're creating a user, create with link 0, link 1, so that tomorrow if you want to delete also it will be easy for me. Okay, and we can also cross check. Don't create with your own name and like this and all, right? So create as a link 0. If you want to create a user, create with link 1, 2, 3, 4 like this. If any users are created, refresh. Currently link 0 and link 1, right? Two users are created. One user created, link 1 is created.
Ravindra,
Yeah.
one question in real-time scenarios, in which cases will be going for delta merge actually?
Delta much mean to say.
In real-time scenario, let us take in BW, we are going to schedule the job. So in daily jobs, whatever the change records will get captured. Same like this in DS, as you said right now, delta merge concept is there to append the data. So in which cases we are going to append, in which cases we are going to make use of this scenario in real time?
Okay, so coming to this, so I will take you with the sample of your BW on HANA. Is it fine? So, for example, you have BW on HANA,
Okay.
and your BW system is BW 7.5,
Okay.
7.4, whatever it is. Now, what I can say is, for example, if you take a cube, there is an info cube, right?
Okay.
The info cube, which table will be there? First is your fact table.
Yes.
There is a fact table. And same like this, you'll have e-fact table.
Yes, e-fact table is it.
E-fact table. Good. Now, one cube will have two tables, e-fact table, f-fact
Yes.
table, fine. So now when I'm trying to load the data into this using DTP, I'll take DTP here and load the data. How many records you have got? Say, for example, 200 records, 1 lakh records. Right.
Yes, yes.
Now, when I load this 1 lakh records into this, or 1000 records, let me take 1000 records. When you load this records using DTP into your fact table, so funda is what, for every column table, there will be internally two more tables, right?
Yes.
One is your delta table, another is your main table. So the moment you try to load the data into DTP, always the DTP will load the data into your delta table only.
Okay.
And this 1000 records will be there in your delta table.
Okay.
Is it fine?
Yes.
Because see, not BW concept, as a HANA concept now, this is a column table, fact table is a column table.
Okay.
And the same column table, if you see here, fact table also, it will be there, but this data will not be there here. But
Yes.
fact table also will have two tables. Column, main table and row table, delta table. But when you load the data using DTP, the first data goes into this and stays here up to 1 hour. Up to 1 hour or 1 GB. Until it is not complete, it will be staying here only. So after 1 hour is over, system will automatically do it. No need to do it manually also. System will automatically merge the data into your table of main table.
Okay.
Then here it will be 1000 records. And this records will be deleted here. Now, putting the data into your delta table will sound good only if it is ERP.
Okay.
Makes sense? So
Yes.
why? Because in ERP, when the records will come, I don't know. Right. So user one has created some transaction, then the data will be inserted where? In your delta table, right?
Yes, delta table.
So the moment I try to write the transaction, so the moment I try to write some data, first record is written directly into this table, means it is inserted here. Then after that, we have, say for example, second record. Then after that, third record, fourth record. Like this, say 100 records are updated. Now, all the writings of your transaction data, what is happening, it will be collected in this delta table only.
Okay.
The moment it reaches 1 GB, for example, after 1 million records, if it has reached 1 GB, then system will merge it automatically into your this table. Cool. So 1 million records will be written into this, and the data which 1 million was there in the delta, this will be deleted. So transaction table, it sounds good for, because we don't want to disturb for every single record, we don't want to disturb there.
Okay.
But in BW, the case is not like that, right? We load the data of 1 million records at a time into your fact table. Is it fine?
Yes, yes.
So 1 million records, I'm writing it immediately here. Then why should I wait again for, though no more records are going to come later, right?
Yes.
So then the moment I load into your delta table, I want it immediately to be merged into this main storage.
Okay.
Right.
Okay.
So into this, I want to merge it immediately, so that what happens is in your DTP, there will be an option called merge delta. The moment I do it, after that I want to trigger it automatically, so that I don't want to wait for another 1 hour. Do it immediately so that my users can see the data immediately.
Okay.
Reporting can be done immediately, and you can see this 1 million records immediately.
Okay.
So when you go to this delta merge function, so you can see in your DTP, right? The DTP, there will be an option here called trigger merge. Now this is only on HANA system, this option will be there. For Oracle, you don't have it.
Okay, okay.
So the moment I click on DTP, it will go to delta. I know that it goes to delta table. Merge it immediately and put it to main table so that user gets the performance immediately.
Okay, okay.
Now, in what cases I will untick this?
Okay.
Right. In the cases like, now for example, I'm loading the data from USA.
Okay.
Sales data 1 million records. Japan, say Europe, some 5-6 countries I'm trying to load the data into the same table.
Okay.
Now what is happening is when I load it again, merge it, it takes some time. By the time there is some other data loading also, again you're merging it in. So why should I merge 5 to 6 times?
Okay.
So let the data gets loaded into your delta table only from all 5 countries. Right? After that, I want to do one merge into your table.
Okay.
So then what will happen is we'll go for the DTP and remove this in the DTP, remove the delta trigger merge. Then after that, load the data for all the 5 countries, whatever is there. When they are completed, then we will have a process here called trigger delta merge.
Okay.
The process chain, we have a process type called trigger delta merge.
Okay.
One time it is done.
Okay.
Is it fine?
Yeah. Okay, Ravindra.
Yeah, that is what happens.
Thank you. Thank you.
Yeah. But again, the problem here when it comes for your DSO, right? When you go for DSO,
Yes.
what will happen is here the data what we are trying to pull is what table? Inbound table.
Mm-hmm.
See, if it is fact table, it is immediately when you click on the triggered delta, then what is happening? The data is going to this one. Immediately it is written to this.
Yes. Yes.
But in the inbound table, and we have, say, for example, active table.
Mm-hmm.
There are 2 tables and change log table, one more table.
Yeah. In DSO.
So then DSO will have 3 tables like this. That means 3 delta tables and 3 main tables.
Mm-hmm.
Now, when you try to insert the data using your DTP, right, and load it, so the data gets loading into this table, and immediately it is going into this one.
Yes.
Getting it? So
Yes.
if you tick this one, it will go immediately to this table of this only. Now, when you activate it, at that time, activation
Activation.
process will copy this one from main to the delta of the active table
Okay.
and immediately merge it. So their trigger merge is not required. So activation itself will take care of it. So from
Okay.
here, it will put the table into this, and again, it will copy the data from here, like that.
Okay.
Right? So in BW, we do it immediately, and only in some rare cases, when some multi or parallel loading is happening for multiple source systems, then only we'll try to untick this and do it. Right?
Okay.
But in ERP systems, like your AC Doka or whatever the even normal databases, we should not merge it immediately. Then we'll lose the performance.
Okay.
Every merge will take some 5 minutes, say for example, then you're losing your performance, right?
Yes.
So we have to wait there after 1 hour only. At one commit, we'll do it. So all transactions which are collected
Mm-hmm.
for 1 hour will be put into that. Like your BWLO, we have Q delta, right?
Yes. Yes. Q delta.
So Q delta is same there how it works out. So it will
Okay.
wait for 1 hour. After 1 hour, it will put all the data, whatever is collected, into your delta table.
Yes. Yes.
Right?
Okay.
Yeah.
Thank you. Thank you.
Rename schema should be there. So rename, give it as rename schema name to then different name. Not tried out, but can try with this. If it is there also, it should be. Name or alter should come into that. So we did Century Link project, we converted it to Century Links. So project to projects.
So we have been asked to create those orders tables in the specific username schemas, right?
Yeah, in the username
Not
schemas
under.
you can create it. Yeah, don't give it your MPID, please. Give it as link 1, link 2, link 3. So because again, for searching, right, we need to search for again with A, B3 and we don't know like where it is. So you can rename it up. You can rename your, what is, for example, with Mahin, what is your ID? No, but that is the ID, employee ID, but what is your link ID? You can just ask the coordinator. No? Okay, I think 13 users are there. You can take up to 16, we got it. So create with user 16. I don't think 16 might be taken by anyone. Can Ravi can check it? Yeah, 16 you can try out. Let me cross check again. Just right click.
Refresh it, few might be deleted.
Yeah, yeah. So, but some users may not yet be created. That's the problem. Only some are created here.
So again, Ravindra, see, in my case, I have created one schema there, and I said owned by link 12. That is what my ID. So now I want to transfer this to HANA, I mean, in case.
Okay. So you have to grant that permission to that user.
You're saying schema, which should be
AB31173 link 16.
73AB.
Okay. So user schema, no? That is personal user schema. So you created a user with that same thing. So
Is it case
it will not
sensitive
be
or
difficult.
something?
Yeah. No, 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 not a thing. See, he has created a user itself as AB3173. Getting it? So
Okay, yeah,
this
yeah.
is
Just
called as a user schema, not a say global schema. So user schema is changed, then user also should be changed. No? So here,
yes, yes.
understood.
So Ravindra, user schema cannot be changed, right? Only global schema can be changed.
That makes sense, no? See, for
Okay.
example, your user schema is what user is created user two, right?
Yes.
User created user two, then schema automatically at that time it is generated as user two. Now, if
Okay.
I change it to, say, for example, Ravi, I cannot change it because tomorrow user schema is checking it. It should be the same name. So because that only makes sense with this, right? The
Okay.
system tells that this is your user schema. Please, you cannot change this, and that also makes sense that user schema should not be changed, right?
Okay.
Yeah. See, for the time being, you can just use it. Not a problem. Yeah, I can create with user 16, link 16 as new one, no problem. You need to create a user with link 16, then automatically it will create with database schema as link 16. So we have link 1, link 2, link 12, link 7. Yeah, so after creating that, so you need to create one project name with the name as Century Links. So once you have created your local user schema has been created, so you want to create one custom schema also. That is, you have to create a schema called create schema century underscore century link underscore project. You give it as project 0. If your ID is 1, give 1. If your ID is 16, give it as 16. Owned by your user, for example, link 16. So your user, even though you're a user, you have a schema. So I want to own this particular project. I'm the owner of this, right? Yeah, link by this one. So when you open your user 16, then under user 16, link 16, you'll be finding this particular project, but others will not be able to see. This particular project, you are the owner, so you'll be able to see. Until unless you grant to others, you will not be able to see it. Okay, fine, not a problem. So for the time being, it's okay. So if you created and done it, no problem, right? Not required. Okay, fine, not a problem. So only for monitoring purpose, it will be easy. Karke, just I was telling. Otherwise, it's fine. Shall I proceed to the next one?
Yes,
Or you
please.
want some time for the
Yes,
practice?
yes. Yeah, good.
Okay. So one more important concept what we have in this is your compression. One more important concept within your HANA database is the compression. This is what the advantage, right? What we have seen, one of the advantages of your using your HANA. So when you see your classical DB, it looks like your normal database, but in your SAP HANA, so we have some 5 types of compressions. So out of this, say for example, by default, or say for example, the initial compression what has been created is your dictionary compression. Now you see that column Intel, Siemens, SAP, IBM. Once you have like this, so your table will create, say for example, one index table. Okay, so we call it a dictionary table. And like your SIDs, for every ID, you will have one numeric ID here. And it try to insert these values inside your columns here. Okay. Now, say for example, Intel, what is ID here? 0. Siemens, 1. So, like your fact table entries, it will try to have all the numerical data entries only. So that, for example, your employee name is Suresh Kumar Satinder Singh, big name is there. Instead of this, you will have 0. How many times he has purchased? 1 lakh times. So 1 lakh times 0 only will be there, but not the big name. Okay. So what is happening is when you do the indexing, for example, you have some 10 GB of your ERP data, then your table will hold only 1 to 2 GB of data. So it is at least 5 to 10 times X it is compressed. So you have 10 TB of data, then you require only 1 to 2 TB of data when you're compressing it. So last time when I shown you, when you're trying to compress, whenever you're trying to merge the data, at the time what is happening there? It is not increasing your main data KB, the KB is still same. So I inserted 100 records, 200 records also. Memory it was say for example 52 was there. So 10 times I increase, so it should be say 500, but still it is 52 because that is due to your compression. So whenever you create your table, compression is not created at all because it doesn't know what type of compression to be created. And the moment you do a first insert and do a merge, at the time of merging, it will create a compression. And the type of compression by default is created is your dictionary compression. Now, over the number of records keep increasing over some millions records, then automatically system will convert into the type of conversion which is what is required. Say, for example, run length compression. In run length compression, what happens is, say, for example, you have Intel. What is ID here? 0. How many times it is repeated? Only 1 time. So 1. Now here Europe, right? Say, for example, Siemens. Now Siemens is repeated how many times? It is, for example, Siemens is 2. 1. So 1 is repeated how many times? 2 times. 2 times. IBM is repeated 1 time. If it is Siemens is repeated 1 lakh times also, then you'll have for one entry, you'll have the number here as 1 lakh is only repeated. Make sense? So this type of compression. So here, in between 1 and this one, say for example, 0 is repeated how many times? 4 times here. But if it is repeated 1 lakh times, then you'll have 1 lakh zeros in the dictionary compression. Whereas in the run compression, here if it is 4 times repeated instead of 1 lakh times, then you'll not have 1 lakh entries, you'll have only one entry with the number as. Is it fine? So Compression is not controlled by us. It happens automatically, right? System decides what type of compression, when to do it, how to do it. But by default, whenever you create a table, then compression is not taken care, right? So compression,
Ravinder,
yeah,
I
yeah.
have question here. Actually, see you saying that it's automatically compression is happening.
Mhm.
So during the data load, it will happen, or like if I created one entry, okay, for the corresponding entry is already present in that like one column. Like if said the Europe is already present, so
Okay.
is it going to not load, or how it is? It overwrite with that existing one? How it do?
See, internally again there will be some other algorithms which will be there. Getting it? See, first time you load it, but again that should be a run length. So run length means what? Now you can see here. Uh, this APA. Okay, here you can see USA is there, right? USA. Now, if you see that USA should be 2, right? 2 times it is repeated, and it should
Correct.
be 1, 2 times, but it will not happen like that. Getting it? So
Correct.
first time when you load the data, then what will happen? USA is there. Then after that there was a continuous data here. Then it will try to make this as 4 entries. Now USA is there. It means making it separately here. Now second time when you load, it will not mix with your own data. That again entry will be as what? For example, in the second time the Europe has repeated 90 times. Then there it will be as 0 and 90 will be there, but it will not mix with your own data there. Got
Okay,
it?
it will add up actually.
Yeah, well, it will make a new entry there. Getting it?
Yeah, got you, got it.
Yeah. So that is what we have in run compression. Cool. So that is one of the advantages of your HANA where it is trying to take it up. Okay. Now, what we will do is we'll take up BW462. I come to the codes what we do this. So normally in the BW, and of course this is a system landscape what we have. So in the real time, so normally in your BW4 certification training, what we try to do it. So there we have S4HANA 1809, and where we will use for ODP and SLT purpose. We try to take this. And for your archiving purpose, to your NLS server, we have Sybase IQDB. Okay, all the cold data we'll try to do it. So this is another server which is configured there, and we'll be having a HANA Studio, then BW for HANA Cockpit, then BW for HANA modeling tools will be there. These are the front end tools which will be there for this. And there it is HANA DB 2.0 SP3, but we have HANA DB SP4. And BW for HANA 2.0 SP0, but we have HANA 2.0 SP1. The latest one version is more with us. And HANA Analytic Cloud is a cloud platform, right? So we need to register or buy a license for that. I think per user license is 1,500 per month. Okay, so minimum is 3 months is required for that, for purchasing it. You want to do it. And one more tool for your front end is your SAP analysis for MS Office. Okay, so this is infrastructure. So within the data, there will be invoice data, some dummy data within the SAP that we need to take up as a ITIO, purchase order and sales order data will be there. So they created some Z tables and we need to pull the data into that and load it. So I'll give some sample data for that. Right. Getting started with the SAP HANA. So it shows in the past we have limited CPU and limited RAM, but now we have got the architecture of your hardwares have gone in such a way that you can have a number of CPUs and number of RAM. Right. Now this is your first release of your HANA was in 2010, and BW powered by HANA is in 2012, and BW for HANA is in release 2016. So these are new developments what has come up. So P star time is purchased by SAP. It's an in-memory row table. Okay. Now, SAP HANA high-level architecture, SAP non-SAP data with your data integration services. Right? What are they? ETL. Then after that, we have got virtualization, then Hadoop, right? So then after that, EAM. So these are all your data integration services. Then we've got data processing services. Okay, so the data processing services, all your engines, everything will be there inside this. And from there, the data gets stored in your SAP HANA in-memory column store and row store, right? And with the front ends like HANA Studio or Web IDE, we try to retrieve the data from this. And on top of this, we'll be having your SAP Bw4Hana, right? This is only the HANA platform. And if you want to do any modeling with your Bw4Hana, that we'll see on Monday. Optimization. So we discussed this and your say row store, column store, compression, partitioning we'll see today only. Okay. Now this is what we have seen it, the difference between your memory things. And we discussed about scale up and scale out, right? Scale up and scale out. So what are the advantages? Row and column, compression, insert only data. So because every transactions, whatever you're doing it, so why do we see more schemas in normal user like AMDP is not coming in 16 mesh? Right, they are all global, right? Say for example, HANA SAP HANA DB is a BW schema. So that is a global schema which is there for all the users. It will be visible for all the users there. Okay. And there will be some system schemas also which will be appearing for all the users. Okay, you're telling that link 16 you don't have this SAP HANA DB. Yeah, because see HANA user we have added that, but when you see this, for example, when you go for so we don't have authorization for that. So then you will not be able to see that schema there. I told you, right? Private schemas you will not be able to see that. And let me reconnect. Yes. Yeah, authorization. You know, because see, for example, I created link 0, right? I don't. Yeah, SAP HANA DB is there because I've taken all your authorizations, right? So whatever the roles we are assigned it, I've taken more roles and it is so that it is coming. You also take all the roles, then it is coming. Okay. Fine. What I was discussing. Now, for example, your say for example, I have got link 0, right? I'm not able to see your user schema, link 16. Getting it? Now you are the owner of link 16. So if you give the grant for that particular schema, then I'll be able to see here. So from your user, what you do is give this command as grant select on schema. Grant select on schema. Link 16 to link 0. You execute from your side. Now I'll refresh. I'll be able to see your schema because you have granted me the rights to that. So execute it. link 16, if you use grant select on schema, link 16 to link 0. Now, once you've done it, when you refresh, still not at home. Did you execute? Just copy the statement and you have to go to your link 16 link. This is your, you have to select the schema link 0. For example, select this link 16, right click, go to open SQL and do from that. To link 0 CTRL, right? See, I can be able to see your CTRL underscore project. So that means you have given me the grant. So now I can have all the rights to see all the tables and create this. Okay. But if he has given me only the table rights, not the whole schema right. So inside the table, 2 tables are there. I'll be able to select only one table only, but not the other table. So then you should not give the schema rights. You should give table rights only. Then leave schema and give as grant select on your table name orders to this user. That is, your user is equal to your schema. So the schema you're doing it right. Grant select, grant delete, like that you can do it. Otherwise, if you want to do it graphically, right? Want to do it graphically, come to the user, link 0, for example. So that is with your SQL we are doing it. Come to this, go to object relation and see. I got link 0 is system has created because the moment I create my user, automatically sys is creating this. Link 12 has given the rights. Grantor is link 12. And link 16 also is granted me. Then when I right click, go to refresh. Then catalog, refresh. Then I'm seeing your link 16, right? Now, this is how we create a global project, and this global project will be given to multiple people so that they only that people will be start working, or not all the people, right? Whoever the grants is given, that will be there. Okay, fine. So let us go for. You can give a total this one. Otherwise, I can give orders. For example, some orders table. See, for example, orders. I try to take orders here. Then you'll tell grant select, grant update, grant delete, insert, drop, or whatever you want to do it. That will give this one. And if this user again wants to grant to others, you want that person who you are granting can grant to others. Then you tell grantable to others. Yes, that this guy can grant to other people also. Otherwise, you will not be able to do it. Okay. How do you see other tables from HANA database which we logged in? That is what, no? So whenever you see the table rights to others, then automatically schema will be there with that particular whatever the tables is there that you'll be able to see. And even though you're able to see others, and we try to click on display data, it will not display data. Okay. Only through schemas you can see it, otherwise it will not be possible. So you can see that one of the things is granted to you. You can see here. Okay, now let's go for modeling now in your SAP HANA. So as a database, we're going to store your data in your HANA database, and say, now what you want to do is you want to utilize this for modeling purpose also. So like your data warehouse, we want to do some modeling also. Then. So we'll take one scenario. Like purchasing queue, we'll create one model. Now, in your BW, what are the objects you have? For master data, what we use? Master data modeling, what we do?
Info objects.
Info objects, yes. Then for your transaction data?
Now the info cubes.
Okay.
And now ADSOs.
We'll forget about ADSO because we're not come to that. So we'll see previous ones only. So info cube should be fine.
Yes, so
And for master data, it is info object. That is a characteristic info object. So
yeah.
Characteristic master data. We'll hold this, and so with attributes, characteristic info object. If you want more attributes, with attributes. Next, transaction data is info cube. So it uses which model? That is your star model.
schema.
Star schema. Now, what is a star schema?
Fact table in the middle, surrounded by number of dimension tables.
So
dimension table linked to the master data.
Yes. This is your fact table, surrounded by multiple dimension tables. I'll take this blue color things as. This is your dimension table. So this is your material dimension. Material dimension, MEN. Next, we have customer dimension, vendor dimension, time dimension. Like this, we have multiple dimensions here. So we'll not go for extended star schema, just simple. Your info cube uses star schema, and your dimension tables are linked to your fact table. And after that, your quantity, price, something with the dimension of this. Okay, now, for example, you created info cubes like sales, and one more info cube is delivery and billing. When you want to combine all these three targets, right? So then what I will do, I'll go for multi-provider. Sounds good? Okay. So we have three targets. That is your sales cube and delivery cube and billing cube. Now when I go for this, so I have this 3 here. I can take this 2. They're all separate. So 3 separate cubes and combining all 3 and making one multi-provider. In the same funda, like your BW, in BW HANA modeling also, for master data modeling, we have something called dimension calculation view. We have in HANA, this is in BW. In HANA for master data model equally to characteristic info object, we have dimension calculation view. Fine. Now, for InfoCube modeling, so we have got calculation view, type cube with star join. And for your multi-provider, for joining multiple cubes or targets, whatever, because multi-provider can not only cubes, DSOs, info objects like this. So here also tables, then your dimensional calculation views or cube with stars and all. So we'll be using a calculation view called view of type cube only, not with. So this is equivalent to multi-provider, and this is equivalent to your multi-provider. Calculation view of type cube and calculation view of type cube with star join is equal to your. This uses your star join. And dimensional calculation view is mainly used for providing a dimension. This will be used like your star join, and it is used to hold your, like for example, material dimension. Now in this dimension calculation view, for example, I got mat ID, mat master, material master, mat master. So we have a table called mat master for material data. And text table is there. I got mat underscore txt as a separate table. Got it? Now like this, you got material plant data. Now what I want to do is I want to combine all these multiple master data tables, like material master table, then after that material plant table and material text table. I want to link all these 3 and make one concrete view as a dimensional calculation view. So I want some out of, for example, there are 10 fields here, there are some 10 fields here, and there are some 3 fields here. So I want 10 means 5 fields from here, 5 fields from here, and 2 fields from here. So totally 22 fields I want to have. 5, 5, 10 plus 2, 12 fields. Okay, just I want 12 fields from there. So this dimensional calculation view is used for creating master data, concrete master data view from multiple tables. And this dimensional calculation view will be used for joining, into your will be used for joining into your fact table. Okay, same like this, retail dimension table. So it has got master data with attributes. What are the attributes you wanted? You can just keep it up here. Sounds good. Now, when you created all your dimensions, material, customer, vendor, and say for example, time dimension. So multiple things you have created here. Dimension. Then we'll go for creating your calculation view of type star join. For performance performance sake, OLAP processor always will give your best performance. Cool. Now, see, normally whenever you have a table, database table, so this is my table. So always table is a two-dimensional rows and columns. So then what language I'll use it in order to fetch the data? So I use SQL language, SQL, sequential query language. But if I have a cube, then what is the language used? Any idea? What is the language for use for your cube in your BW also? It is your MDX, right? So MDX is multi-dimensional expressions because it cannot use SQL directly. It has to be converted into your, normally your Vex query will convert this into your MDX query. So that is your multi-dimensional expressions. MDX. So whenever you have multi-dimensional model, MDM model, not two-dimensional, MDM model, we use the language for MDX. Cool. Fine. Now, for this particular models, we have seen that for dimensional calculation views, it will be using your tables only for joining here. So in the HANA, we have a join engine. So dimensional calculation will be processed by which engine? Join engine. So dimension calculation view is being executed by join engine. And your cube with star join, with the star structure, will be processed by your OLAP engine. One more, your calculation view of type cube will be executed by your calculation engine. You want to join some multiple targets, multiple calculations or complex calculations are there. Have been done with your calculation engine. Fine. So these are the three engines which are involved in your HANA server. Okay. So first, what we will do is we'll try to go for a join engine. So that is your dimensional calculation view. Then after that, we'll create one cube. Then after that, we'll try to create a multi-pivot structure like your calculation engine. Right? Now, so we'll not take more dimensions. So I will take a metal master is one file. In the file, we have metal master data and text is there. Plant data is not there. So we'll try to take two tables only for creating your material dimension. Then for your customer dimension, I have got a table called cust underscore master. Single table. Okay. I got a single table called customer underscore master. So we'll take two simple dimensions, and your fact table is your orders, what we created now. We'll take orders as a table. So table names, I put with color. Okay, orders. The table is what? Customized and material master and material text. Okay. Let's do this. Now, All these models, as I told you, will be grouped under your package. We have to create one package here. So for our practice, we'll create one package called link 0. Under link 0, we'll create two more sub packages called sales, another is finance. Under sales, we'll create your calculation view. That is your calculation views. Naming conventions, if it is dimension calculation view, we'll give it as CVD underscore mat underscore master, middle master. And for your dimension calculation CVD bandpass, we will create CVD underscore test underscore master. Two dimension calculation views. Okay. And we'll give this name of this cube as CVS, means start join, CVS underscore August. Should be fine. Two dimension calculation views and one start join calculation view. We'll try to create it. Now, let me go to link 0. Then within this link 0, just take out catalog, take out this. Under the content, right click, go to new, create a package. In the package name, make it as link 0. Okay. Control C, Control V. Same thing will be there. Automatic pop-up. So just give it up. Now delivery unit is for transportation purpose. Okay. This we'll see later. Now click on OK. So we got one link 0 created. Under this, create one more package called sales. So don't remove this prefix, otherwise it will again create in the root content folder. So it's a sub package. So prefix is this sales. Now select this, click on OK. Again, right click. If you say click on this, you'll have sales here. Right click the parent. It's same like info area. One more package called finance. So we created two sub areas, but we under sales we'll create our calculation view. Right? Just create it so that package level at least we are in sync. Create all your packages, right? So this one you can remove it. CenturyLink, you don't keep it like this. So I'm just removing from here. Create in sequence so that it will be in one particular line.
Ravindra, if you are speaking something, you are on mute.
Yeah, so thing is, when you go to user 16, link 16, you don't have any roles here. Link 16 is not having any role. So what is the role you require? Modeling role. Okay. So better take what are the roles you can take it. I just drag and this system privileges also take whatever can be granted. Take all. If it is not granted, it will tell that there is an error for that. Not a problem. So click on activate. Okay. Now try out. Because a simple thing modeling is sufficient for me, but for any other thing also you can take it. Right? So this is sales and finance. Two models for this. One is sales, another is finance. Two things. So under this, nothing is there. We'll create later. So first link, then sales and finance. Sub packages for this is if you want still more, then you can create it. Finance means accounts receivable, accounts AP, you can do it, but it's fine. Two models are okay. Okay, package. So just right click this, go to new, view the package, and give a name to the package. So it should be after the link. This is the parent, after that the child. After the dot again other child, like this. No, nothing like it's fine because it's only like info area we don't have any other limit, right? So like this, it's only a folders like it's not a problem. It is not creating any table something, so it is just like a label, right? You can create it, no problems. Normally in HANA, so if you see that, maximum number of locks, maximum sessions, 8,192. Database size limit by storage sizes 1 TB. Okay, 1 TB of data can have within your database, one single database. Maximum number of tables in a schema, so 131072, 131,072 tables. So like this, tables and views, maximum number of columns in a table is 1000. Maximum length of a row, 1 TB. Maximum number of indexes for each table, 1023. Maximum number of primary keys, 16. Index 16. Length of SQL statement, maximum length can be 2 TB of the length space, right? Group by statement, maximum number of columns in the group by statement. So like this, we have the limitations which are created to this. Okay, start doing it. Okay, now next I'll continue so that it's a simple creation only. But still some links are blank. Yeah. Yes, m_system limits. You want to see this? And the type of errors, whatever you have it. So normally we have this implementation here, and the different types of errors what we have in this. Why whatever transaction error, whatever errors, we have the list again. Okay, now I'll go for the next one. So what we'll do is in this link 0, we'll try to create the tables which are required for master data, right? Go to the catalog, go to your link 0, link, press on L. That is the HANA database schema, link 0. And it will schema here, link 0. Now, just click on this. Okay. Now open the SQL check given to this. Go to the file and recent. We have a metal master table which we created. So create column table mat underscore mast and take the statement, try to insert it. So create column table mat underscore mast, mat ID giving this primary key. Then mat group type this blank course. Just you want to do it one by one. So just click on first create table. Then after that insert this particular insert statement. Okay. So material master table is created. Second, below this, take this material create material text, Control C. Now Control A and Control B. Right? So material master and your text language. This is a material text table. I have mat IDs, pras, and material description. Now click on execute. Right? Now we have created two tables. One is your master data and text table. In BW also we have material master table and text. But there in extended star schema, we are trying to take separate tables and link it individually. The system does it. Now for this two tables, I want to create one calculation view. That is your dimensional calculation view. Now let's go for your content. Go to link 0 under the sales. Right click, go for create new and click on create the calculation view. Right? So what you have to do, right click the package, select this as calculation view and give the name as CVD underscore material dimension, right? Material dimension. So CVD underscore material is fine. So we think that it is a material dimension. And in the bottom data category, you need to select this as dimension. Right? Now click on finish. So give the name, category type is important, then click on finish. Now what happens is you want to join two tables. So then you need to select this join node and drag and drop into this. Right? Drag and drop into this. In the join statement, I will select two tables. So by the side you can see that there is a plus mark, or you can right click here, go for add objects, whichever is easier for you, you can do it. Otherwise you can go to the schema also and drag and drop from there. Right? So go to add objects, view it as mat underscore must. Mat must, and that is your link 0. You should take from your schema because other schema tables you will not be able to have the access. So link 0, click on OK. You can see this in your material master. Now right click again, go for add object, view it as mat underscore txt. Material text table. Select this from your schema. We have this. Now whenever you want to select these fields from this to this, then I want material, metal group, material type, whole metal ID, plan, but I don't want company code, for example, right? Or I don't want whole metal ID. I'll just remove this and I'll go for company code. Next. Now from here, I want only the language and the description because metal ID is already selected here, so I don't want. Now select this field, drag and drop this. Okay. The type of join what I'm taking here is an inner join by default what is that. So let it keep, no problem. Now from this, what you do is when you select here, you drag and drop to your projection. So this output of this field, because this is the output fields what you try to see. Now sometimes what happens is you have already taken metal ID here, and if you double click this again, it will create one more alias for this. If I double click again, it will create one more field for this. Sometimes these mistakes can happen. So what you do is just right click this, click on remove. Again, right click on remove. Fine. Now, in SAP HANA, so we have two types of fields. The fields what we have in HANA are known as attributes. One more is measures. So attributes are nothing but your characteristic info objects, and measures are your key figures. Okay. So these are your characteristic. And this is your key figures. Now, here, when I go for projection, I want all the fields because in projection, if you want to still filter out some fields, for example, you have 100 fields which is the output you're getting at, and you want to project only some 50 fields to the top node, and what you can do is you can just tell, okay, I want this, I don't want metal group, or metal group, metal type is required, and other things I don't want it. Then if you see in the semantic only, we have 3 fields. But currently, I'll take all the fields, just select it, and when you see the semantic, then you can see that these are fields which are dynamics. Now, what you have to do is, when you see the type of data here, this is an attribute. So master data dimensions are always attribute fields. You cannot create any measures because we are not aggregating the data in the dimension calculation. So dimension calculation always 100% they are attributes only. Once it is done, then you need to check the syntax, check the model. Then after that, click on save and activate. Okay, so I'm trying to do it activation directly, but now what will happen is it will fail, because normally for this user, you can see that it will fail here because we have a problem with the user is not authorized. Okay, so then what authorization we should have it? Anyone is already in this?
Grant access.
Grant. What you will grant it?
So schema grant access.
Yeah, so to which user you have to give?
Link 0.
Again? Okay. So here, what happens is, whenever you're creating some models, a user is creating some models, now every object should be registered in the repository. Okay. So it should be registered in the repository. So without that, you cannot generate any model. So for that, what you have to do is, from your user link 0, right? From your user link 0, you need to grant yourself your schema to sysrepo. So even admin also will not be able to do it. So you can give this statement as grant select on schema. Grant select on schema. Your schema name is what? Link 0 to underscore sys underscore repo with the grant option. Okay. So you need to link your you should have the permission. You should give the permission for the repository to do the activation. So grant select on schema link 0 to sysrepo with grant option. Just click on execute. Now done. Now go back to your model. Now again activated. Now it is done successfully. So once done, by this side you can see here there is a data preview button. And when you go to the raw data here, and click on the raw data. Now you see metal ID, metal group, metal type, this is this. Now SPRAS and your metal description is coming from your text table.
We lost your screen share.
Is it? Okay. Okay. So now,
yeah.
when you see this, so now you can see that the raw data is there, whatever is there in the data, how it is output of the dimension calculation view, you can see here. Now, when you want to see the distinct values within the SAP HANA calculation view itself, now drag and drop this. Okay, this many distinct values. Okay, now metal type plant, how many plants are there? How many company codes are there? Right? How many descriptions are there? Metal ID will be always unique, primary key. Metal group should be like this. But when you want to see this like a chart, then let me take this metal group. Now for a chart, I should have y-axis also. Then I'll take drag and drop metal group here. I can see like this. Now you want to change this to vertical bar, or you want to take dual axis, or you want to take this as 3D one, right? Go to horizontal line chart, like your business objects, right? How you're trying to do this? This you can just do this with this. Cool. Fine then. So this is for one dimension calculation view where you're trying to use a join statement. And remember that in a join, you cannot keep one table. Minimum two tables should be there. And normally here, this node will accept only two tables, not more than this. So we have seen some students, what they're doing is they take a single table also for a join and try to do it up. So that mistake will come in the next one. So the same way like this, let us create one more calculation view. That is your CVD underscore. So, okay, let me create a table first. So in the sheet, we have customer master table. So let's take the data for this and create one table. Link 0, link 0, control V. Now try to go for execute. So customer table is created. Now I have only single customer table. I don't have any other table. So then I go for my calculation view. New, we create CBD underscore customer underscore must customer dimension. Now take this as dimension because it's a master data dimension for this. Well, now I don't have any other tables to link up. So what I can do is I can directly take this customer table, that is cust underscore must link 0 to this. Right? Now you see this. Now if you want to select all the fields, there are some 100 fields. Instead of selecting all the fields, right click on the table, you'll have add all to output. So at a time you can select it. Right? Go to semantic, all are attributes only, and click on activate. Done. Fine. So I created two dimensions. Now what we'll do is let us create one calculation view type star join. Now I want to combine these two master tables with your transaction table, that is your orders. Now right click this, go to new, give it as CVS underscore orders. Right? Now here you have to select here as cube with the star join. Right? This is important for us. So this is view one model as calculation view type star join. Now click on finish. So here the node before it was not a projection now, but it is a star join now. Now here I can just add up your dimensions and fact tables, but I don't have any fact table here. So in order to have the fact table, what I will do is I will take the node as aggregation node here. So aggregation node will do a group by statement for your measures, right? So I'll take an aggregate node, click on this and go for orders table, orders within link 0 and click on OK. Cool. Orders table within your fields here. Now here, what we have to do is just right click this for your easiness. We'll rename this aggregation one to facts or order underscore facts. Click on OK. Now from this, what happens is, like when I select this order field, so when I click on this, right click on this, you can see add as an aggregated column and add to output. So if it is a attribute, you should make it as add to attribute, and if it is a measure, you have to take it as aggregated column. Okay, so this one is what a normal attribute. This is the attribute because it should not aggregate. Attribute. But order quantity is what it's a measure, right? Where you can sum. So right click this, take it as add as a calculate column. Then you can see that there is a sum here. This will be doing a sum by order quantity. Then your price also, I'll make it as add as an aggregate column. Now when you see here price, say for example you have here some, you want to take the minimum quantity or max price of that, only one price you want to take it, you can max price of that. Now you can take this as currency, then after here. So quantity and price only will be the aggregated columns, and remaining things you can take it as normal fields. Now when I go to the start join, I don't have any fact table, so I should link this fact table to your start join. Now when I go to the fact table, sorry, start join, you can see that order fact. So the orange color is what we have is your fact table. Cool. So now if you want all the fields from this, you can right click, go for add output. So I want all the fields from here. Now your fact table should be linked with your dimension tables. What are the dimension tables here? Customer and material. What you can do is you can right click from here or click on this, you'll have a plus button so that you can add your dimensions. What is this? CVD underscore material. You can just add from this particular add point. So the blue color one is your dimension table. Or if you want to put this customer, right? You want to add the customer to this customer dimension to your model, you can drag and drop here also. That is another method, or you can directly take it into your output details screen. So we have taken two dimensions, material dimension, customer dimension, and one fact table. Now select the material ID and drag and link to your mat ID within this table. So by default, when I selected your material ID in the fact table should be removed. In two places we will not have it. So let me keep it in the dimension table only. And customer ID I have already taken here. So this customer ID will remove this link from here. So no need to display two times customer ID. So one is sufficient. So now select this, drag and drop into this. So material ID dimension is linked to this fact table, and customer ID is linked to your table of customer ID. Okay. Now when I go to the semantic here, the semantics we mentioned what type of fields we should behave like. So we have two areas. One is known as local, another is a shared. Right? Now, shared means to say these dimension calculation views are not created locally. They are being shared, already created, and we are trying to share in this particular model. So they are known as shared models. So what are they? Material. They are all dimensions. Already the semantics is already done in the model, and this is customer is already there. And if you want to see whatever things are linked, shared here, these are the fields. Next, we have the model for the semantic type in your local model. So order ID should not aggregate, right? It provides a context, so select it as attribute. Now, order quantity should be what? It's a measure. But if you want the system to suggest automatically, then the last button, what you find here is an auto assign. System will see the data type and makes automatically select the field. Sometimes what happens if your order ID is a number, like 1001 and 002 is a number, the system will automatically make that field as measure. So it's not 100% correct, but what you do is do it so that maximum 70%, 80% will be done. So 20% again recheck it and change wherever it is required, right? So once the semantic type is done, then go for activate. So in the activation, we find this activation job running, and once it is created, right, we can go for a review of the model. Now go to data raw data. So you want to see the whole data, what is coming out from your cube, right? This is the whole data, what is coming from your cube. So material ID data is this. From here, it is customer data, what is trying to link to this. Then after that, your orders data. All the 12 orders will be displayed. Now, if you want to see this like your report, how it comes, take your order quantity, then order price, how it is coming here. Or you want to see for the selection, for this only the selection, how the data looks like a table, or a grid, or a HTML view. These three are the same only, but it's fine. Good. Now for each country, you want to see how many metal groups are there inside this. So data-wise is like this, but if you want to see in the chart, so enter India, we have 2 metal groups. For USA, there are 4 metal groups. So like this, we can make the analysis for this. Okay. So let's model now. So take up your customer, material dimension, and one orders cube, right? Chalo then, let's start with some practice.